Look up at the night sky. What do you see? A scattering of stars, perhaps the faint glow of the Milky Way. But what if I told you that beyond those quiet points of light, the universe is alive with unimaginable spectacles, explosions so powerful they can outshine entire galaxies, collisions where stars are torn apart in brilliant displays, and vast clouds of cosmic gas painting the heavens in colors no artist could ever replicate. This isn't just space, it's a grand, dynamic theater where the most extraordinary events unfold on a scale so vast, it's almost impossible to comprehend. And today, we're going to witness 48 of these celestial wonders together, each one more breathtaking than the last. Think about the last time you felt truly small under the night sky, that humbling sense of awe as you realize just how vast the cosmos is. Now multiply that feeling by 1,000, because what we're about to explore isn't just distant points of light, it's the universe in motion, supernova detonating with the energy of 1 billion suns, black holes bending light and time itself, nebulae where new stars are born in swirling clouds of dust and gas. These aren't just abstract concepts, they're real, tangible events happening right now across the unimaginable distances of space. And the best part, you don't need a telescope to experience them. Through the power of science and storytelling, we're going to bring these cosmic marvels right to you. So why 48? Because the universe doesn't do things by halves. Every one of these events tells a story of creation, destruction, and the endless cycle of rebirth that defines our cosmos. Some of them will leave you speechless with their beauty, others will challenge everything you thought you knew about space, and a few might even send a shiver down your spine as you realize just how mysterious, how vast, and how utterly spectacular the universe truly is. This isn't just a journey through space, it's a journey through time, through physics, and through the very limits of human understanding. So take a deep breath, lean in, and let's begin. The cosmos is waiting. Let's kick off with a storm so vast, so relentless, it could swallow our entire planet without breaking a streak, Jupiter's great red spot. Picture this, a swirling vortex of crimson clouds, wider than Earth itself, churning for at least 400 years. That's right, while human civilizations rose and fell, this tempest raged on, a perpetual hurricane in an atmosphere without solid ground to slow it down. What fuels such a monstrous storm? Jupiter's a gas giant, a ball of hydrogen and helium with no surface to dissipate energy. Its winds scream at speeds over 400 miles per hour, whipped into frenzy by the planet's furious rotation spinning so fast, a day there lasts just 10 hours. But here's the twist, the great red spot isn't just shrinking, it's changing shape. Once oval enough to fit 3 Earths side by side, it's now more circular, like a cosmic wheel slowly wearing down. Scientists are racing to understand why. Some think Jupiter's turbulent jet streams are stealing its energy, while others suspect hidden heat dynamics deep within the planet's layers. One thing's certain, this storm is a living laboratory, challenging everything we know about atmospheric physics. Imagine a hurricane on Earth surviving for centuries, then multiply that by 1,000. That's the scale of chaos we're dealing with here, and the color, that eerie red hue, it's still a puzzle. Some theories suggest sunlight breaks apart chemicals like ammonia and acetylene high in Jupiter's atmosphere, creating compounds that glow crimson. Others point to sulfur or phosphorus rising from deeper layers, painting the storm like some alien artist's brushstroke. Whatever the cause, the great red spot isn't just a spectacle, it's a window into the violent, beautiful chaos of gas giants. And as it slowly fades, we're left with a humbling thought. Even the mightiest phenomena in the cosmos are fleeting, bound by laws we're only beginning to grasp. From the swirling storms of Jupiter, we now travel 7,000 light-years away to a celestial masterpiece, the Pillars of Creation. These towering spires of cosmic gas and dust, rising like ancient skyscrapers in the Eagle Nebula, aren't just breathtaking to behold. They're stellar nurseries, cradles where new stars are born. The Hubble Space Telescope first captured their haunting beauty in 1995, an image so iconic it became a symbol of the universe's creative power. But what makes these pillars so extraordinary? Imagine clouds so dense, so massive, they collapse under their own gravity, sparking the fusion reactions that ignite infant stars. Inside those dark, dusty veins, pockets of gas heat up, glow, and eventually burst forth as brilliant new suns. Yet there's a tragic irony here. The same radiation and stellar winds that give these pillars their ethereal glow are also tearing them apart. The brightest stars nearby, young, violent, and searingly hot, blast the pillars with ultraviolet light, evaporating the very material that birthed them. It's a slow but inevitable erosion, like sand sculptures facing an eternal tide. Scientists estimate these structures may vanish entirely within the next 100,000 years, a blink in cosmic time. But even as they dissolve, their legacy endures. The stars they've spawned will outlive them, carrying fragments of their origins across the galaxy. What's truly mind-bending is how much we've learned from this one snapshot. Infrared observations pierce through the dust, revealing hidden stars still forming within the pillars' shadows. Some of these protostars are so young, they haven't even begun nuclear fusion, yet cosmic embryos wrapped in swirling disks of debris, future planetary systems in the making. And then there's the scale. Those pillars stretch light-years tall, dwarfing our entire solar system. Yet despite their grandeur, they're fragile, temporary artworks in the vast gallery of space. This dance of creation and destruction isn't unique to the Eagle Nebula. It's happening everywhere. But here, we see it framed with unmatched clarity, a reminder that beauty in the universe is often fleeting, balanced between birth and decay. The Pillars of Creation don't just show us how stars are made. They teach us about impermanence, about how even the most majestic structures are part of an endless cycle. And somewhere in those glowing tendrils of gas, there's a lesson. The cosmos doesn't build to last, it builds to transform. In the vast darkness of the Large Magellanic Cloud, a star that had burned for millions of years suddenly decided to go out with a bang, and what a bang it was. On February 24, 1987, Earth's telescopes caught something extraordinary: the violent death throes of a blue supergiant star, now known as Supernova 1987A. For a brief, glorious moment, this explosion outshone its entire host galaxy, becoming visible to the naked eye, even from 160,000 light-years away. It was the closest observed supernova in nearly 4 centuries, and it gave astronomers a front-row seat to one of the universe's most dramatic events, a star tearing itself apart in a cataclysm of light and energy. But what exactly happens when a star goes supernova? Picture a cosmic balancing act gone wrong. For most of its life, a star like this one fights a constant battle between gravity crushing inward and nuclear fusion pushing outward. Then, in its final moments, the fusion furnace sputters, gravity wins, and the core collapses at nearly a quarter the speed of light. The shockwave rips through the star's outer layers, blasting them into space with the force of 100 million suns. The result, a fireball so bright it can outshine entire galaxies, and a shockwave that sends ripples through the fabric of space itself. Supernova 1987 didn't just put on a show, it revolutionized astronomy. For the first time, scientists detected neutrinos from a dying star, ghostly particles that slipped through Earth hours before the light arrived, confirming theories about how supernova work. Then came the real surprise, the glowing hourglass-shaped debris field left behind. Instead of expanding evenly, the explosion sculpted rings of gas, like cosmic smoke rings, lit up by the dying star's final energy. And at the heart of it all, a newborn neutron star, a city-sized remnant so dense a teaspoon of its material would weigh 1 billion tons. This event was more than just a light show. It was a cosmic recycling plant in action. The explosion forged heavy elements, gold, uranium, even the iron in your blood, and scattered them across space. Without supernova like this one, planets like Earth and life itself wouldn't exist. And here's the wildest part, we're still learning from it. Decades later, telescopes watch as the shockwave slams into pre-existing gas rings, creating glowing hotspots that change year by year. It's a slow-motion autopsy of a star's death, and every new observation peels back another layer of mystery. Supernova 1987 reminds us that destruction and creation are two sides of the same coin. A star dies, but in doing so, it seeds the universe with the building blocks of new worlds and new possibilities. And somewhere in that expanding cloud of debris, there's a lesson written in stardust. Even in death, the cosmos finds a way to give birth. In the year 1054, something extraordinary happened in the night sky, something so bright, so impossible to ignore, that astronomers across China and the Middle East wrote it down in their records. A new star appeared, shining 6 times brighter than Venus, visible even in broad daylight for 23 days. What they called a guest star was actually the violent death of a massive sun, an explosion so powerful its light traveled 6,500 years to reach Earth. Today, we know that celestial fireworks display as the Crab Nebula, a swirling cloud of gas and dust that's still expanding at nearly 900 miles per second. But here's the thing, this isn't just a pretty cosmic relic. It's a powerhouse, a natural particle accelerator, and one of the most studied objects in the sky. At the heart of the nebula lies the real marvel, a pulsar spinning 30 times every second, faster than a helicopter blade. This city-sized neutron star is the crushed core of that long-dead sun, so dense that a single sugar cube-sized chunk would weigh as much as Mount Everest. And it's not just spinning, it's pulsing like a cosmic lighthouse, beaming out radiation across the entire electromagnetic spectrum with such precision, you could almost set your watch by it. The energy it releases lights up the entire nebula, making the gas glow in eerie blues and reds, a ghostly reminder of the star's final moments. What makes the Crab Nebula so special isn't just its history, it's how much it's taught us about the universe. Back in the 1960s, astronomers realized this nebula was emitting gamma rays, X-rays, and radio waves, making it the first recognized source of cosmic high-energy radiation. It became a Rosetta Stone for astrophysics, helping scientists decode how pulsars work, how supernova enrich the cosmos with heavy elements, and even how particles can be accelerated to nearly the speed of light. When the Hubble telescope focused on it, the images revealed intricate filaments of gas, twisted into knots and braids by magnetic fields stronger than anything we could ever create on Earth. But the surprises didn't stop there. In 2011, scientists detected gamma-ray flares from the nebula so intense, they defied explanation, bursts of energy that shouldn't be possible under existing physics models. It's as if the Crab Nebula is still challenging us, still dropping clues about the extreme limits of nature. And every time we think we've figured it out, it throws another curveball our way. Here's the real kicker. We're watching this nebula evolve in real time. Compare photos taken 50 years apart, and you can actually see the gas expanding, the filaments shifting, the pulsar slowing ever so slightly as it loses energy. It's like having a time lapse of cosmic history unfolding before our eyes, and somewhere in that swirling cloud is a message, a reminder that the universe doesn't just create and destroy. It recycles, it transforms, and it leaves behind clues for those who know how to look. The Crab Nebula isn't just a tombstone for a dead star. It's a classroom, a laboratory, and one of the most fascinating time capsules the cosmos has ever given us. On a clear, moonless night far from city lights, you can see it with your bare eyes, a faint, fuzzy patch in the constellation Andromeda, that unassuming smudge of light. That's an entire galaxy, 2.5 million light-years away, hurtling toward us at 250,000 miles per hour. The Andromeda Galaxy isn't just our closest galactic neighbor, it's a mirror showing us the Milky Way's fate, a time capsule of stars so vast it makes our own galaxy look almost modest by comparison. With nearly 1 trillion stars, twice as many as the Milky Way, Andromeda isn't just another spiral in the cosmic sea. It's a titan, an island universe so close we can study its individual star clusters, its swirling arms, even the faint glow of its trillion-year-old stellar halo. What makes Andromeda so special isn't just its scale, it's the intimate details we've uncovered. Hubble's sharp eye has spotted over 400 globular clusters orbiting it, each a dense ball of hundreds of thousands of ancient stars. Some of its satellite galaxies, like tiny M32, are being slowly ripped apart by Andromeda's gravity, leaving trails of stars like cosmic breadcrumbs. And then there's the double nucleus at its heart, two dense clumps of stars orbiting one another, likely the aftermath of a smaller galaxy being digested by Andromeda billions of years ago. This galaxy isn't just sitting there, it's a dynamic, evolving beast, growing larger by cannibalizing its neighbors. But here's the mind-bending part. Andromeda and the Milky Way are on a collision course. 4 billion years from now, gravity will pull these two galaxies into a slow-motion dance that will last billions more. Stars will fling past each other like grains of sand in a hurricane so far apart that actual collisions are rare, but close enough to rewrite the night sky forever. Computer simulations show the merger will warp both galaxies into a new, elliptical shape, their spiral arms erased by the chaos, and at the center, their supermassive black holes will spiral together, unleashing gravitational waves that ripple across the universe. Yet for all its grandeur, Andromeda holds mysteries we're still unraveling. Why does it have so much less dark matter than our models predict? How did it grow so massive so early in the universe's history? And most tantalizing, could some of its planets harbor life? With hundreds of billions of stars, the odds are good that Andromeda has rocky worlds in habitable zones, perhaps even civilizations gazing back at our galaxy, wondering the same things we are. Andromeda isn't just a distant spectacle, it's a reminder that galaxies aren't static islands. They breathe, they collide, they evolve, and one day, far in the future, our descendants, if humanity still exists, will look up at a sky where the Milky Way and Andromeda have merged into a single, unrecognizable glow. The stars we see today as separate will be mingled, their stories intertwined. It's a humbling thought. Even galaxies, those seemingly eternal structures, are just temporary patterns in the universe's grand tapestry. And Andromeda, it's not just our neighbor, it's our future. Hidden in the sword of Orion, where newborn stars blaze with blue-white intensity, a shadowy figure emerges against the glowing backdrop of interstellar gas, the Horsehead Nebula. This isn't just another cloud in space, it's a cosmic sculpture, a towering pillar of dust 3 light-years tall, carved by stellar winds into the unmistakable profile of a horse's head. What makes this silhouette so mesmerizing isn't just its shape, but how it defies the very nature of nebulae. While most stellar nurseries glow with vibrant colors, the Horsehead thrives on darkness, a dense knot of gas and dust so thick it blocks the light from the glowing hydrogen gas behind it. But don't let the darkness fool you. This nebula is anything but empty. Peer into its inky folds with infrared telescopes, and you'll find a bustling stellar nursery. Young stars, still swaddled in cocoons of gas, are taking shape within those shadowy depths. Some are barely 1,000,000 years old, infants by cosmic standards, already heating their surroundings and slowly evaporating the very material that birthed them. It's a race against time. These stars must gather enough mass to ignite fusion before radiation from nearby massive stars blows their nursery apart, the Horsehead's iconic shape. That's the work of Sigma Orionis, a scorching hot star just outside the frame. Its fierce ultraviolet radiation acts like a cosmic chisel, eroding the nebula's edges and sculpting that distinctive profile. Yet, even as it's being worn away, the nebula fights back. Magnetic fields thread through the dust like invisible wires, providing structure and slowing the erosion, giving fledgling stars precious extra time to form. Here's what's truly astonishing. We're witnessing a snapshot of a fleeting moment. In another few million years, a blink in cosmic time, the Horsehead silhouette will be gone, dissolved by starlight. But its legacy will live on in the stars it nurtured, some of which may one day host planets of their own. This delicate dance of creation and destruction plays out all across the galaxy, but rarely with such poetic symmetry. The Horsehead Nebula isn't just a dark cloud, it's a reminder that even in the blackest corners of space, there's light waiting to be born. And there's another lesson here, written in stardust and shadow. The same forces that destroy also shape, that erode also reveal. Without the relentless stellar winds, we'd never see that iconic silhouette. Without the chaos of radiation, new stars wouldn't be pushed to form. The Horsehead Nebula teaches us that darkness isn't the absence of creation, it's often the canvas on which creation unfolds. So the next time you gaze at Orion's belt, remember, that famous horse isn't just a shadow. It's a cradle, a work of art, and a ticking clock all at once. Gaze 28 million light years into the Virgo constellation, and you'll find one of the universe's most photogenic galaxies, the Sombrero. This cosmic marvel isn't just another spiral. It's a celestial masterpiece, its edge on profile so perfectly framed by a dark, razor-thin dust lane that it looks less like a natural formation and more like a meticulously designed sci-fi backdrop. But here's the twist. That iconic silhouette isn't just for show. Every detail of this galaxy, from its brim-like dust ring to its glowing central bulge, holds clues about the violent, beautiful processes that shape galaxies across the cosmos. What makes the Sombrero Galaxy so special starts with scale. That central bulge isn't just bright, it's monstrous, packed with ancient stars in such tight formation that astronomers suspect a supermassive black hole lurks at its heart, one with the mass of 1 billion suns. Surrounding it, a disk of younger stars and gas so flat, so perfectly aligned to our viewpoint, that the galaxy's spiral arms, normally visible face-on, compress into a single, crisp dust lane. This isn't just a hat, it's a galactic bullseye with rings within rings. Infrared telescopes reveal a second, fainter dust lane further out, like concentric ripples frozen in space. But the real mystery isn't just how the Sombrero looks, it's how something so symmetrical survives in a universe ruled by chaos. Most spiral galaxies show warps, twists, or asymmetries from collisions and gravitational tugs. Not this one. Its pristine structure suggests an unusually quiet life, free from major mergers that typically scramble galactic shapes. Yet paradoxically, its halo teems with globular clusters, over 2,000 of them, far more than the Milky Way's 200. Some astronomers think this excess hints at a violent past where the Sombrero cannibalized smaller galaxies, absorbing their stars while somehow keeping its flawless disk intact. Then there's the dust lane itself, a cosmic conveyor belt of future stars. Unlike the fragmented dust clouds in many spirals, the Sombrero's ring is continuous, almost polished, as if some unseen hand swept the debris into perfect alignment. Radio observations reveal cold gas molecules there, the raw material for new suns waiting to be ignited. But here's the catch: star formation in the Sombrero is oddly subdued. Despite all that pristine material, the galaxy isn't birthing stars at the expected rate. Some process, perhaps magnetic fields, or that titanic central black hole is pressing pause on creation, leaving the dust lane to glow faintly like an unlit fuse. The Sombrero Galaxy challenges our assumptions at every turn. It's a spiral that behaves like an elliptical, a tranquil beauty with a potentially violent past, a star-making factory that hesitates to produce. And that's what makes it so invaluable to science. By studying this cosmic oddity, we're not just admiring a pretty space picture, we're decoding the rulebook of galactic evolution, one paradox at a time. Its perfection isn't just art, it's a question written in starlight, asking us to rethink how order emerges from chaos. And somewhere in that dark, elegant brim, there's a lesson. Sometimes the universe's most profound secrets hide in plain sight, dressed as something deceptively simple. Some celestial dances take eons to unfold, but few are as breathtakingly clear as the Whirlpool Galaxy and its companion. Known officially as Messier 51, this stunning spiral galaxy isn't traveling alone. It's locked in a slow, gravitational embrace with a smaller neighbor, NGC 5195. Together, they paint a cosmic portrait of destruction and rebirth, a preview of what happens when galaxies collide. The Whirlpool's grand spiral arms, usually tightly wound, have been stretched and distorted by their gravitational tug of war, unraveling into sweeping arcs of blue-hot young stars and pink nebulas where new suns ignite. This isn't just a static snapshot, it's a live action drama playing out over cosmic time. As the smaller galaxy tugs at the Whirlpool's outer edges, shockwaves ripple through its gas clouds, compressing them until they collapse into brilliant new stars. The evidence is written in those vivid blue clusters, each one a stellar nursery sparked by the chaos of the merger. But here's the twist: this interaction isn't just creating stars, it's also stealing them. Streams of stars and gas stretch between the two galaxies like cosmic bridges, material slowly being siphoned from the smaller companion into the Whirlpool's hungry grasp. What makes this pair so extraordinary is how clearly we can see the process unfolding. Most interacting galaxies are too distant or too messy to study in detail, but the Whirlpool lies just 23 million light-years away, close enough for telescopes to pick out individual star-forming regions. Hubble's images reveal intricate dust lanes threading through the spiral arms, backlit by the glow of newborn stars. Infrared observations show something even more surprising. The smaller companion isn't just a passive victim, it's triggering star formation in the Whirlpool's core too, sending shockwaves deep into its heart. This dance won't last forever. Simulations suggest the smaller galaxy will eventually be torn apart, its stars assimilated into the Whirlpool's halo, a fate that awaits many satellite galaxies, including some orbiting our own Milky Way. But the real lesson here isn't about destruction, it's about transformation. Every close encounter between galaxies reshapes them, leaving behind brighter cores, reordered spiral arms, and new generations of stars. The Whirlpool's beauty isn't despite the chaos, it's because of it. And that's what makes this cosmic waltz so vital to understanding our future. When the Milky Way and Andromeda collide billions of years from now, they'll follow a similar script. gravity distorting their shapes, gas clouds colliding to birth new stars, and eventually two becoming one. The Whirlpool Galaxy isn't just a spectacle, it's a time machine showing us where we're headed. And somewhere in those swirling arms, there's a reminder. In the grand scheme of things, even galaxies don't get to stay unchanged forever. Among the most exquisite farewells the universe offers, few compare to the delicate symmetry of the Butterfly Nebula. 2,400 light-years away in the constellation Scorpius, this cosmic masterpiece unfurls across space like luminous wings, each gaseous lobe stretching nearly 2 light-years from tip to tip. What we're witnessing isn't chaos but precision, the carefully orchestrated final act of a star not unlike our Sun, now shedding its outer layers in a slow-motion ballet of light and matter. The secret to these perfect wings lies in the star's death throes. As it exhausted its nuclear fuel, the dying Sun didn't collapse evenly. Instead, it ejected material in opposing jets at speeds over 600,000 miles per hour, sculpted by powerful magnetic fields or possibly the gravitational tug of an unseen companion star. The result, a rare bipolar nebula, where twin lobes of gas expand outward while a dense equatorial belt of dust pinches the waist, creating that unmistakable hourglass shape. Ultraviolet radiation from the exposed stellar core, now a white dwarf hotter than 200,000 degrees, lights up the expelled gas, making it glow in vivid blues and oranges across Hubble's images. But here's what makes the Butterfly truly special: those intricate structures within the wings. High-resolution photos reveal delicate tendrils, shock waves, and even bow shocks, where faster-moving gas plows into slower material. It's like watching smoke rings frozen mid-expansion, each ripple telling a story about the star's final millennia. Some filaments streak outward at 90 degrees to the main wings, suggesting the dying star wobbled like a spinning top as it ejected material, a celestial fingerprint of its death spiral. This isn't just stellar death, it's cosmic recycling on grand display. The expelled material, rich in carbon, nitrogen, and oxygen, will eventually mix with interstellar clouds, becoming raw material for future stars and planets. Every atom in those glowing wings might one day end up in an alien ocean, a distant mountain range, or perhaps even life forms we can scarcely imagine. The Butterfly Nebula reminds us that endings in the universe are rarely absolute, they're transformations, rearrangements, and often breathtakingly beautiful ones at that. What's haunting is how fleeting this spectacle is. Nebulae like this dissipate in just tens of thousands of years, a blink in cosmic time. We're catching this one at its peak, its delicate structures still intact before they fade into the interstellar darkness. It's a privilege of timing, a reminder that the universe is constantly changing, and that today's celestial wonders might be tomorrow's invisible dust. But for now, the Butterfly Nebula spreads its luminous wings wide, a final, glorious flourish from a star that refused to fade quietly into the night. Behold the Ring Nebula, a celestial halo so flawless, it looks like a cosmic jeweler crafted it. Floating 2,300 light-years away in the constellation Lyra, this glowing blue and green ring isn't just beautiful, it's a stellar autopsy, the aftermath of a star's final breath. What makes it extraordinary isn't just its symmetry, but the violent chaos required to create something so precise. Most dying stars spew their outer layers in messy, irregular bursts. But here, against all odds, the result is near-perfect geometry, a bubble of gas expanding with such uniformity, it defies expectations. The secret lies in the star's death spiral. As it ran out of fuel, the core contracted, heating up until it blasted away its outer atmosphere in pulses. But instead of scattering randomly, that material was funneled into twin jets, sculpted by the star's rotation and magnetic fields. Imagine squeezing a balloon at the poles. The gas escapes equatorially, creating a ring, now scale that up to stellar proportions, with forces so intense they warp the fabric of space itself. The outer layers, now unshackled from gravity, drift outward at 40,000 miles per hour, illuminated by the exposed white dwarf at the center, a searing ember hotter than the sun's surface. But here's what's eerie: the Ring Nebula isn't actually a ring. Hubble's sharp eye revealed it's more like a football-shaped bubble of gas, with a ring effect created by our edge-on view. Peer through a telescope, and you're seeing the dense equatorial glow, while the poles stretch toward and away from us, too faint to detect. It's a cosmic illusion, a trick of perspective that makes this nebula one of the sky's most iconic and misunderstood wonders. What's unfolding here isn't just a star's death, it's a preview of our sun's fate. 5 billion years from now, our home star will undergo the same transformation, shedding its layers in a glowing shroud that might one day dazzle alien astronomers. But the real magic is in the details. The Ring Nebula's gas contains oxygen, carbon, and nitrogen elements forged in its core, and now destined to seed future stars and planets. That blue-green glow, it's stardust literally recycling itself in real time. Yet even this pristine ring won't last. In about 10,000 years, the gas will disperse into the void, leaving the white dwarf to cool over trillions of years. For now, though, the Ring Nebula stands as a celestial monument, a reminder that even in death, stars create beauty, symmetry, and the very elements that make new worlds possible. It's not just a cosmic circle, it's a promise that endings can be as breathtaking as beginnings. Deep in the heart of the Large Magellanic Cloud, a satellite galaxy orbiting our Milky Way, there's a cosmic beast spinning a web of starfire, the Tarantula Nebula. This isn't just any stellar nursery, it's the most furious, prolific star factory in our entire galactic neighborhood, a place where stars aren't just born. They erupt into existence with such intensity, they rewrite the rules of stellar formation. Spanning over 1,000 light-years, this colossal cloud of gas and dust churns with the energy of tens of thousands of young, massive stars, each one blazing hotter and dying younger than anything in our own galaxy. At the nebula's core lies a true monster, R136A1, the most massive star ever discovered. Clocking in at over 250 times the mass of our Sun, this stellar leviathan burns so fiercely, it emits nearly 9 million times more light. Stars like this shouldn't exist according to traditional models. Their own radiation pressure should tear them apart before they reach such sizes. Yet here they are, defying physics in a dazzling display of cosmic excess. The ultraviolet radiation from R136A1 and its siblings is so intense, it carves vast cavities in the surrounding gas, sculpting towering pillars where the next generation of stars is already taking shape. But the tarantula isn't just about creation, it's about destruction as a creative force. The stellar winds from these massive stars rip through the nebula at millions of miles per hour, triggering shock waves that compress nearby gas clouds until they collapse under their own gravity. It's a self-perpetuating cycle. The very forces that tear the nebula apart also provide the pressure needed to birth new stars. Some of these shock waves even escape into intergalactic space, sending ripples of star-forming potential across the Large Magellanic Cloud. What makes this nebula truly unique is its scale and violence. Most star-forming regions in our Milky Way, like Orion, seem tranquil by comparison. The tarantula's stars form in dense, frenzied clusters, with supernova detonating so frequently, their remnants overlap like bubbles in a cosmic foam. This constant bombardment of energy keeps the nebula from collapsing under its own weight, creating a self-regulating ecosystem where star formation continues at a breakneck pace. Yet even this chaos has structure. Hubble's sharp eye has revealed intricate networks of dust filaments, like the strands of a spider's web, channeling gas toward dense knots where protostars ignite. Some of these filaments stretch for hundreds of light years, weaving through the nebula in patterns that suggest hidden magnetic fields guiding the chaos. And tucked between the brilliant star clusters are dark globules, dense cocoons where stars may be forming right now, shielded from the radiation that would otherwise evaporate them. The Tarantula Nebula is more than a spectacle, it's a laboratory. Here, we see how the first stars in the universe might have formed, in an era when galaxies were smaller, gas was purer, and everything burned brighter and faster. It challenges our textbooks, forcing us to reconsider how extreme environments shape stellar evolution. And somewhere in that maelstrom of light and gas, there's a lesson. The universe doesn't just make stars gently. Sometimes it forges them in fire and fury, writing its grandest stories in the scars left behind. Gaze into the depths of Draco, and you'll find an emerald eye staring back. The Cat's Eye Nebula, a cosmic masterpiece so intricate it seems almost impossibly designed. This isn't your typical planetary nebula. It's a Russian nesting doll of stellar death, with 11 concentric rings of gas wrapped around a brilliant core like the layers of an onion. Each shimmering loop tells a story of violent outbursts spaced 1,500 years apart, pulses where the dying star ejected its outer layers in fits and starts, creating this hypnotic layered effect. But here's what truly baffles astronomers. Stars don't usually die in such precise, rhythmic tantrums. At the nebula's heart lies the culprit, a white dwarf so hot it makes the surface of our sun seem chilly by comparison. Radiation from this exposed core lights up the expelled gas, creating that signature green glow of ionized oxygen. Yet the real marvel is the nebula's bizarre symmetry. Twin jets of gas shoot outward at right angles, sculpted by powerful magnetic fields into hourglass-shaped lobes, while shockwaves ripple through the surrounding rings at speeds over 4 million miles per hour. This isn't a peaceful expansion, it's a stellar explosion frozen in intricate detail, like a firework captured mid-burst. Hubble's razor-sharp images reveal even wilder details, knotted filaments, braided gas streams, and even spiral structures near the core that suggest the presence of an unseen companion star. Some theorists believe this ghostly partner could explain the nebula's complexity. Its gravitational tugs might have yanked material into those perfect rings during each eruption, like a spoon stirring cream into coffee. Others point to the dying star's rotation and magnetic fields as the architects of this precision. What's undeniable is that we're witnessing a stellar swan song conducted with unnatural perfection. The Cat's Eye also holds a chilling lesson about our sun's fate. In about 5 billion years, our star too will shed its layers, though likely without such dramatic flair. But here's the twist. The nebula's central white dwarf is massive enough that it may one day go supernova, detonating in a final act of cosmic rebellion. For now, though, it glows quietly within its jewel-like shroud, a reminder that even in death, stars can create beauty beyond imagination. Those glowing rings aren't just debris, they're a time capsule, preserving the final millennia of a star's life in gaseous hieroglyphics we're only beginning to decipher. What makes the Cat's Eye truly extraordinary isn't just its beauty, it's the unanswered questions. Why 1,500 years between eruptions? How did the jets maintain such perfect alignment across millennia? Every new observation peels back another layer of mystery, proving that even the most studied objects in the sky can still surprise us. This cosmic feline isn't just watching from the darkness, it's challenging us to unravel its secrets, one shimmering ring at a time. Just below Orion's belt, where the hunter's sword would hang, lies a cosmic jewel box, the Orion Nebula. This isn't some distant, fuzzy speck requiring powerful telescopes to appreciate. On a clear winter night, far from city lights, you can spot its faint glow with your naked eye, a smudge of mist in the constellation's blade. But that humble appearance belies the chaos within. What you're seeing is the closest massive star-forming region to Earth, a mere 1,300 light-years away, giving us front-row seats to the birth of stars and planets on a scale unmatched anywhere else in our galactic neighborhood. Step into this glowing cloud with infrared eyes, and the nebula transforms into a bustling stellar maternity ward. 4 massive young stars, known as the Trapezium cluster, dominate the heart of the nebula, their ultraviolet radiation so intense it carves out a cavity in the surrounding gas and lights it up like a cosmic lantern. These stellar titans are mere infants, less than 1,000,000 years old, yet already shaping their environment with hurricane-force winds. Their energy excites the hydrogen gas, making it fluoresce in vivid pinks and reds, while reflected starlight paints the dust clouds ethereal blues. The result, a celestial watercolor where physics and beauty collide. But the real magic happens in the shadows. Behind those glowing veils of gas lie dark, dense knots called protoplanetary disks, each one a potential solar system in the making. Hubble's sharp vision has captured over 700 of these disks, some as large as our solar system, where dust grains collide and stick together, forming the first seeds of future planets. In a few million years, some of these disks may give rise to rocky worlds like Earth or gas giants like Jupiter. We're not just looking at star birth, we're witnessing the origins of potential homes for life. What makes the Orion Nebula truly special is its accessibility. Unlike distant star-forming regions, this one's close enough for telescopes to pick out individual newborn stars still cocooned in their gas envelopes. Some of these protostars are so young, they haven't even begun nuclear fusion yet, cosmic toddlers taking their first steps. Others blast out jets of material at hundreds of miles per second, punching through the surrounding gas like interstellar fire hoses. These jets, often aligned along magnetic field lines, create glowing bow shocks that mark where the stellar winds slam into slower-moving nebula material. The nebula isn't just making small stars either. Deep within its dusty folds lurk massive stars in the making, ones that will eventually outshine our sun by factors of tens of thousands. These behemoths form differently than their smaller counterparts, gathering mass through complex networks of gas filaments that funnel material toward them like cosmic rivers feeding a growing giant. Their eventual births will flood the nebula with even more intense radiation, triggering new waves of star formation in an endless cycle of creation. Yet for all its violence, the Orion Nebula is fleeting. The very stars it births will eventually blow away their natal cloud, dispersing the nebula's gas across interstellar space. In another few million years, this glowing masterpiece will fade, leaving behind an open cluster of stars, some with planets, some alone, as its only legacy. We're catching it at the perfect moment, when the balance between creation and destruction paints the most spectacular portrait. So the next time you spot that faint smudge in Orion's sword, remember, you're not just seeing a cloud in space. You're glimpsing the universe's workshop where raw gas transforms into suns, worlds, and perhaps, one day, new possibilities for life itself. The Orion Nebula isn't just a sight to behold. It's a mirror showing us our own origins, written in starlight and cosmic dust. Staring into the depths of Aquarius, you'll find an unblinking cosmic eye gazing back. The Helix Nebula, a sprawling death shroud of a star so vast it spans nearly 3 light-years across. This isn't just another planetary nebula. It's one of the closest and most meticulously detailed, offering us a front-row seat to the fate awaiting our own sun. From our vantage point on Earth, we peer directly into its face-on structure, as if the universe itself arranged this celestial pupil to lock eyes with us across 650 light-years. What makes the helix so mesmerizing isn't just its scale, it's the haunting complexity of its structure. Hubble's images reveal a labyrinth of radial filaments, like spokes on a wheel, stretching outward from the central white dwarf. These aren't random tendrils, they're the fingerprints of a dying star's final convulsions, where knots of denser gas resisted evaporation long enough to cast long shadows through the expanding nebula. Surrounding them, concentric rings ripple outward like water droplets frozen mid-splash, each one a snapshot of material ejected in pulses over thousands of years. It's as if the star gasped its last breaths in rhythmic bursts, leaving behind a fossil record of its demise. At the heart of this cosmic iris glows the star's remnant, a white dwarf hotter than the surface of the sun, its ultraviolet radiation lighting up the expelled gas in ethereal blues and greens. But here's the twist, that glow isn't uniform. The inner regions shine with ionized oxygen, while farther out, nitrogen tints the rings red, creating a gradient that mimics the depth of a real eye. This chromatic layering isn't just for show. It's a chemical timeline, revealing how different elements were dredged up from the star's interior during its death throes. The helix's most haunting feature, though, are those ghostly cometary knots, dense globules of gas and dust, each one twice the size of our solar system, trailing luminous tails like celestial tadpoles. These knots are the last remnants of the star's planetary system, perhaps the evaporated cores of gas giants or the shattered remains of icy bodies, now baking under the white dwarf's harsh glare. Their tails point radially outward, sculpted by the same stellar winds that are slowly eroding them, a poignant reminder that even planetary systems aren't eternal. What's truly humbling is the timeline we're witnessing. The outer rings of the Helix Nebula began expanding over 12,000 years ago, around the time humans first domesticated wheat. By contrast, the inner structures are mere infants, some only a few millennia old. Yet in cosmic terms, this entire spectacle is fleeting. Within another 10,000 years, the nebula will dissipate into invisibility, leaving the white dwarf to cool alone in the dark. The Helix Nebula isn't just a celestial curiosity, it's a mirror. In its intricate layers, we see the future of our own solar system, a preview of the sun's fate 5 billion years from now. But there's beauty in this inevitability. The same carbon, oxygen, and nitrogen glowing in those rings will one day recycle into new stars, new planets, perhaps even new life. The universe doesn't mourn its dead, it repurposes them. And somewhere in that glowing eye, there's a silent message. Endings here are never final. They're just the universe's way of clearing the stage for its next act. Stretching across the constellation Cygnus like a celestial spiderweb, the Veil Nebula glows with an eerie luminescence, the ghostly aftermath of a star that tore itself apart over 10,000 years ago. This isn't just debris scattered through space. It's a cosmic crime scene frozen in time, where delicate filaments of ionized gas trace the path of a supernova's shockwave as it plows through interstellar space at 500,000 miles per hour. What makes this remnant extraordinary isn't just its scale spanning 110 light-years, but how vividly it preserves the violence of its birth. Every twist and knot in those ethereal strands tells a story of unimaginable forces colliding, heating gas until it glows in vivid reds from hydrogen, blues from oxygen, and purples from sulfur, painting the heavens with the star's elemental fingerprint. Zoom in with Hubble's eye, and the nebula reveals its secrets. Those seemingly fragile filaments are actually turbulent ridges where the shockwave meets slower-moving interstellar material, like waves crashing against a cosmic shore. The brightest edges places like the witch's broom or Pickering's triangle mark, where the shock front compresses gas to temperatures of millions of degrees, causing it to emit X-rays detectable by space telescopes. Yet between these glowing walls lie vast, almost empty bubbles where the explosion's energy has carved out cavities, leaving behind a lacework of light and shadow. It's a stellar autopsy in progress, with each strand acting as a clue to the star's final moments. Here's what's truly astonishing: we're witnessing this cataclysm in extreme slow motion. When this star detonated, human civilizations were just beginning to record history. The light from that explosion reached Earth around 5,000 years ago, likely visible as a sudden guest star to ancient skywatchers. Now, millennia later, the expanding debris field has thinned enough for us to see through it, revealing structures so intricate they resemble neural pathways or the veins of a cosmic leaf. The Veil's transparency is its gift, unlike younger supernova remnants shrouded in dust. Here we can study the full three-dimensional structure of stellar death with unprecedented clarity. But the Veil Nebula isn't just a relic. It's an active participant in the galaxy's life cycle. Those shockwaves are forging new molecules in their wake, including complex compounds like hydrogen cyanide and carbon monoxide. As the expanding shell sweeps up surrounding material, it's also triggering the collapse of nearby gas clouds, seeding future star formation. Even in death, this star is shaping its corner of the cosmos, proving that destruction and creation are inseparable partners in the universe's grand dance. What's haunting is how temporary this beauty is. In another few thousand years, the Veil's filaments will dissipate into the interstellar medium, their atoms destined to be recycled into new stars, planets, or perhaps even life. For now, though, it stands as one of the sky's most poignant reminders, a testament to the fact that even the most violent endings can leave behind something breathtaking. The Veil doesn't just show us how stars die. It whispers that every ending is laced with the promise of beginnings yet to come. Drifting through the constellation Monoceros like a cosmic rose in full bloom, the Rosette Nebula unfolds its petals across 130 light-years of space. This isn't just another cloud of gas, it's a celestial garden where stellar winds sculpt delicate cavities, painting the cosmos with hues of crimson and sapphire. At first glance, the nebula's symmetry seems almost artistic, a perfect floral arrangement suspended in the void. But peer closer, and you'll find chaos at its heart, a cluster of massive young stars known as NGC 2244, blazing with such intensity they've blown a colossal hole through the nebula's center. These stellar infants are the architects of the Rosette's beauty, born just a few million years ago, a mere blink in cosmic time. They're already reshaping their surroundings with hurricane-force winds and searing ultraviolet radiation. Imagine a cosmic blowtorch meeting a cloud of vapor. That's essentially what's happening here. The star's energy carves away at the surrounding hydrogen gas, ionizing it until it glows pink like neon, while dust particles reflect starlight in ethereal blues. The result, a natural masterpiece where physics and artistry collide. But the Rosette's magic isn't just skin deep. Hidden within its dusty folds lie hundreds of protostars, sun-like babies still wrapped in their natal cocoons. Infrared telescopes reveal these embryonic suns as faint heat signatures, some still gathering mass from swirling disks of debris. A few are even ejecting jets of material at supersonic speeds, punching through the nebula like tiny fireworks. This is star formation in action, a dynamic process where gravity and radiation wage an endless tug of war. What makes the Rosette truly special is its transparency. Unlike many nebulae shrouded in opaque dust, this one's relatively clear, letting us see clear through its central cavity to the stars beyond. It's like having X-ray vision for stellar nurseries. The nebula's famous petals aren't solid structures but the edges of vast bubbles regions where denser gas resisted erosion, forming delicate walls between the hollowed-out zones. Yet even this floral giant has an expiration date. Within a few million years, the central stars will likely explode as supernova, their shock waves scattering the remaining gas across interstellar space. For now, though, the Rosette Nebula stands as a fleeting work of art, a reminder that even in the vacuum of space, nature finds ways to bloom. And somewhere in those glowing petals, there's a lesson. The universe's most breathtaking sights often arise from its most violent processes. Drifting through the constellation Sagittarius like a cosmic tide, the Lagoon Nebula stretches its glowing arms across 55 light-years of space, a stellar nursery so vast and luminous, you can spot its hazy glow with binoculars from Earth's surface. But this isn't just another pretty cloud of gas. It's a celestial battleground where the forces of creation and destruction wage war, sculpting a landscape of glowing hydrogen ridges, dark dust tornadoes, and star clusters blazing with newborn intensity. The name Lagoon comes from the striking divide slicing through its center, a shadowy lane of cooler dust that splits the nebula like a tropical inlet, with radiant stellar winds carving out hollows that resemble tidal pools under a cosmic sunset. At the heart of this glowing sea lies Herschel 36, a young, monstrous star 40 times the mass of our Sun, burning so fiercely it's melting away its own nursery. Its ultraviolet radiation ionizes the surrounding hydrogen, making it fluoresce in pinks and reds, while stellar winds blast outward at nearly 5 million miles per hour, pushing against the nebula's gas like a cosmic plow. The result, a colossal cavity where the walls glow as bright as city lights seen through fog. But the real magic happens at the edges, where compressed gas collapses into new stars, hundreds of them, some still wrapped in veils of dust, others blasting out jets of material like interstellar geysers. Zoom in with telescopes like Hubble, and the lagoon reveals its secrets. Dark Bok globules, dense knots of gas and dust float like shadowy islands against the glowing background, each one a potential cocoon for protostars. Nearby, the open cluster NGC 6533 sparkles with young, hot stars, their collective light eroding the nebula's gas even as their gravity binds it together. It's a paradox. The very stars born from this chaos are also dismantling it, their radiation sculpting the nebula into ever-changing shapes. What makes the lagoon truly extraordinary is its transparency. Unlike many nebulae shrouded in thick dust, this one's relatively clear, letting us peer deep into its star-forming factories. Infrared views reveal tendrils of gas swirling like underwater currents, funneling material toward hungry young stars. Some of these infant suns are surrounded by spinning disks of debris, future planetary systems in the making. Others eject material in bipolar jets, carving hourglass-shaped cavities that glow like celestial lanterns. Yet the lagoon's beauty is fleeting. Within a few million years, the most massive stars will explode as supernova, their shock waves scattering the remaining gas across space. For now, though, it stands as a vibrant snapshot of stellar evolution, a place where darkness and light, creation and destruction exist in perfect dynamic balance. And somewhere in those glowing tides there's a lesson. The universe doesn't just build stars gently. Sometimes it forges them in the crucible of chaos, writing its grandest stories in the interplay of shadow and radiance. In the heart of Sagittarius, where the Milky Way's dense star fields shimmer like scattered diamonds, lies a cosmic chameleon, the Trifid Nebula. This isn't just another glowing cloud in space. It's a celestial three-in-one wonder, blending emission, reflection, and dark nebulae into a single breathtaking canvas. The name Trifid comes from its dramatic division into three distinct lobes by dark, obscuring dust lanes like a cosmic peace sign etched in starlight and shadow. But these aren't arbitrary lines. They're the seams where different astrophysical processes collide, offering us a front-row seat to the universe's creative diversity. The crimson glow dominating the nebula's eastern side is pure emission nebula hydrogen gas ionized by the fierce ultraviolet radiation of newborn stars, particularly the massive HD 164-492A. This blue giant burns 30 times hotter than our Sun, its energy exciting the surrounding gas until it fluoresces in vivid pinks and reds. But shift your gaze westward and the palette changes dramatically. Here, fine dust particles scatter the starlight, creating an ethereal blue reflection nebula that shimmers like cosmic fog under a celestial spotlight. The same physics that turns Earth's sky blue operates here on an interstellar scale, with microscopic dust grains redirecting starlight toward us in a soothing azure glow. Then there are the dark lanes thick, inky rivers of dust so dense they block all light behind them. These aren't empty voids but cold, molecular clouds where future stars are taking shape. Infrared telescopes pierce through these obscuring curtains to reveal protostars buried within, some still gathering mass from swirling disks of gas. The contrast couldn't be starker. While one part of the Trifid blazes with stellar radiation, another remains a frigid nursery, its potential locked away in darkness. What makes the Trifid truly extraordinary is how these three regions interact. The boundary where emission meets dark nebula is a star-forming frontier, a place where radiation and shockwaves from the bright side compress the dark cloud's gas, triggering new rounds of stellar birth. Meanwhile, delicate tendrils of dust stretch like bridges between the lobes, sculpted by magnetic fields and stellar winds into surreal, filamentary shapes. Hubble's close-ups reveal evaporating gaseous globules, dense knots of gas resisting erosion, each one potentially cradling a fledgling star system. But the Trifid's drama doesn't stop there. At its heart lies an open cluster of young stars, their fierce winds carving out a central cavity. Some of these stars are mere infants, still embedded in the nebula's fabric, while others have already blown away their birth cocoons. Their collective energy shapes the entire nebula, proving that even in space, youth has the power to reshape its surroundings. This cosmic trifecta isn't just beautiful, it's a time capsule. The Trifid captures different stages of stellar evolution simultaneously: the searing radiation of mature stars, the gentle scattering of light by dusty remnants, and the silent gestation of new suns in the dark. It's a reminder that the universe doesn't operate in singular modes but in symphonies of interconnected processes. And somewhere in those threefold lobes, there's a deeper truth. To understand the cosmos, you can't just study its parts. You have to see how they dance together. Gliding through the constellation Sagittarius like a celestial swan, the Omega Nebula spreads its luminous wings across 15 light-years of cosmic pond. Officially catalogued as Messier 17, this stellar nursery doesn't just glow. It hums with the energy of newborn stars, their ultraviolet radiation sculpting the surrounding gas into ethereal shapes that shift and shimmer across the spectrum. From afar, its most iconic feature curves gracefully like a swan's neck, a delicate arc of ionized hydrogen glowing in vivid pinks and reds. But zoom in, and the serenity gives way to ferocious creativity, a place where stars are born in violent bursts, rewriting the nebula's structure with every stellar gasp. What makes this nebula extraordinary isn't just its beauty, it's the physics behind the glow. At its core, a cluster of massive young stars, some barely 1 million years old, blast their surroundings with radiation so intense it strips electrons from hydrogen atoms. When those electrons recombine, they release energy as light, painting the nebula in that signature crimson hue. But the Omega's palette doesn't stop there. Sulfur emissions add golden streaks, while oxygen tints certain regions turquoise, creating a watercolor effect that shifts depending on which elements dominate each pocket of gas. This isn't random splatter, it's a chemical map revealing how different layers of the nebula respond to stellar radiation. The swan-like shape itself is a cosmic illusion, a trick of perspective and structure. Those elegant curves are actually the edges of a vast, hollowed-out cavity. Think of a soap bubble where one side has eroded more than the others. The neck marks where denser gas resisted evaporation, forming a glowing ridge between the stellar winds and the untouched interstellar medium. Infrared observations peel back the visible light to reveal even grander scales. Dark tendrils of cold dust weaving through the nebula like submerged roots, funneling material toward new generations of stars still taking shape in the shadows. But the real drama lies in the details. Hubble's close-ups show tiny, dark globules peppering the nebula, dense knots of gas and dust called Bok globules, each one a potential stellar womb. Some of these dark specks are already collapsing under their own gravity, their cores heating up as protostars ignite within. Nearby, brighter patches betray the presence of Herbig-Haro objects, jets of material spewed by infant stars as they accrete mass from surrounding disks. These jets, often aligned along magnetic field lines, punch through the nebula at hundreds of miles per second, creating shock waves that glow like celestial fireworks. The Omega Nebula is more than a static painting, it's a dynamic ecosystem. The same radiation that lights it up is also eroding it, blowing away gas and dust that might otherwise form more stars. Yet in that destruction lies creation. Shockwaves compress nearby gas, triggering new rounds of star formation in an endless cycle. It's a reminder that even the most serene cosmic vistas are born from chaos, their beauty etched by forces both creative and destructive. And somewhere in those glowing tendrils, there's a lesson about time. That what we see as a swan today may, in another million years, transform into something entirely new as the universe continues its slow, magnificent dance of reinvention. Imagine a cosmic battleground where stars wage war against their own birthplace. That's the Carina Nebula, a sprawling stellar factory stretching over 300 light-years across. This isn't just another glowing cloud in space. It's a theater of extremes where newborn stars shine with such ferocity they tear apart the very gas that birthed them. At its heart lies Eta Carinae, a hypergiant star so unstable it makes supernova look tame by comparison. This volatile beast has erupted twice in human history, once in the 1800s when it briefly became the second brightest star in Earth's night sky, and again in the 1990s, ejecting enough material to form 10 planets. Today, it lurks within a dusty shroud, its fate hanging in the balance between collapse and cataclysmic explosion. What makes Carina extraordinary isn't just its size, it's the sheer violence of its stellar inhabitants. The nebula's most massive stars pump out ultraviolet radiation so intense, it carves the surrounding gas into surreal formations. Towering pillars like the Mystic Mountain rise 3 light-years high, their summits glowing under the relentless stellar onslaught, while their bases shelter fledgling stars from the radiation storm. Nearby, vast cavities gape where stellar winds have blown bubbles in the nebula, leaving behind delicate filaments that shimmer like cosmic cobwebs. This is creation through destruction. The same forces that erode the nebula also compress its gas, triggering new rounds of star formation in an endless cycle. Hubble's images reveal Carina's chaos in breathtaking detail. Dark globules of dust pepper the nebula like celestial ink blots, each one a potential stellar nursery. Jets of material streak outward from infant stars, their shock waves lighting up the surrounding gas in ethereal blues. Some regions glow gold with the light of heated dust, while others fluoresce crimson from ionized hydrogen. It's a color palette no artist could invent, a natural masterpiece painted by physics at its most extreme. But the real drama lies in the timeline. The Carina Nebula captures multiple generations of stars simultaneously, from ancient clusters fading into obscurity to protostars still cocooned in dust. Eta Carinae itself may be on borrowed time. When it finally explodes, the blast could outshine the moon in our night sky. Yet even that catastrophe will sow the seeds for future star formation, proving that in the cosmic dance, death and rebirth are partners. The Carina Nebula doesn't just show us how stars live and die, it reveals how chaos and beauty are entwined on the grandest scales imaginable. In the constellation Norma, where the Milky Way star clouds shimmer like scattered fireflies, a cosmic insect spreads its wings, the Ant Nebula. This isn't your typical planetary nebula. It's a masterpiece of symmetry, with twin lobes of gas stretching light years into space, perfectly mirrored as if some celestial sculptor had crafted them with meticulous care. Those delicate antenna-like jets aren't just beautiful, they're a profound mystery, challenging everything we thought we knew about how stars die. Most dying suns shed their outer layers in messy, irregular puffs. But here, against all odds, the result is near-perfect bipolar precision, a stellar swan song conducted with unnatural elegance. At the heart of this cosmic ant lies a white dwarf, the collapsed core of what was once a star not unlike our sun. Its searing ultraviolet radiation lights up the expelled gas, creating that signature green-blue glow of ionized oxygen. But the real enigma is those lobes. Hubble's razor-sharp images reveal intricate structures within them, knots, shocks, and even faint braided filaments, hinting at multiple eruptions spaced thousands of years apart. Some astronomers believe the dying star didn't just exhale its atmosphere gently. It coughed in fits and starts, with each pulse sculpted by powerful magnetic fields or the gravitational tug of an unseen companion star. The ant's most baffling feature, those ultra-fast jets shooting along its polar axis at speeds over 600,000 miles per hour. These aren't random squirts, they're precision-engineered outflows, narrower than our solar system yet stretching light years into space. One theory suggests the star's spin and magnetic fields focus these jets like cosmic nozzles, channeling material into tight beams. Others propose the influence of a binary partner, a second star whose gravity could have funneled the dying sun's ejector into those symmetrical lobes. Whatever the cause, the result is a celestial Rorschach test where astrophysics and artistry collide. But here's what truly astonishes. The Ant Nebula isn't just showing us how stars die, it's revealing how they manipulate their surroundings. Those jets have plowed through interstellar space, sweeping up material and creating shock waves that glow in X-rays. The lobes themselves are expanding into pre-existing gas, leaving ripples in their wake like a boat speeding through cosmic waters. This isn't a peaceful process, it's a violent reshaping of the local universe, proof that even in death, stars leave fingerprints on their corner of the galaxy. What makes the ant so invaluable to science is its clarity. Most bipolar nebulae are too distant or too obscured by dust to study in detail, but this one. It's close enough, about 8,000 light-years away for telescopes to dissect its structure almost molecule by molecule. Every new observation peels back another layer of mystery, from the chemical composition of its jets to the subtle asymmetries that betray hidden dynamics. The ant doesn't just challenge our textbooks, it dares us to rethink how complexity emerges from simplicity, how order can arise from chaos, and there's a haunting lesson in its wingspan. Within another few thousand years, those luminous lobes will dissipate into the interstellar void, leaving the white dwarf to cool silently in the dark. For now, though, the Ant Nebula stands as a fleeting masterpiece, a reminder that the universe's most profound puzzles often come wrapped in beauty, and that even the smallest cosmic phenomena can hold the biggest surprises. Gazing into Gemini, you'll find a celestial elder staring back the Eskimo Nebula, its frost-rimmed hood etched against the blackness of space like an ancient face preserved in cosmic ice. Officially catalogued as NGC 2392, this planetary nebula isn't just another dying star's shroud. It's a layered masterpiece, its intricate structure preserving the violent mood swings of a sun like star's final millennia. That iconic parka of glowing filaments, those are shockwaves frozen in time, stellar material ejected in fits and starts over thousands of years, now sculpted by radiation into a shape both haunting and familiar. What makes the Eskimo truly mesmerizing lies beneath its furrowed hood. Hubble's razor-sharp vision reveals not one but two distinct shells, an outer halo of older, slower-moving gas and an inner bubble of more recently ejected material. This nested structure tells a story of stellar instability, where the dying star didn't shed its atmosphere evenly but in heaving gasps, like a cosmic lung collapsing in slow motion. The inner shell blisters outward at nearly 90,000 miles per hour, its leading edge plowing into the older halo like a snowplow carving drifts, creating those characteristic radial spikes that give the nebula its textured, woolly appearance. The central star itself, now a white dwarf hotter than the sun's surface, is the architect of this icy spectacle. Its ultraviolet radiation excites the expelled gas, making oxygen glow teal and nitrogen blush crimson, while delicate dust grains reflect starlight in ethereal blues. But here's the twist: those seemingly delicate filaments are anything but fragile. They're cosmic battlefronts where stellar winds collide with slower-moving material, creating shockwaves visible as knotted tendrils in high-resolution images. Some of these filaments stretch over a light year long, their braided structures suggesting the influence of powerful magnetic fields during the star's death throes. Perhaps most intriguing are the cometary knots, dense globules of gas with glowing tails, each one larger than our solar system. These aren't just debris, they're the evaporated remnants of the star's planetary system, perhaps the scorched cores of gas giants or the shattered remains of ice worlds, now baking under the white dwarf's harsh glare. Their tails point radially outward like weather vanes in a stellar hurricane, marking the direction of the relentless radiation wind. The Eskimo's beauty is fleeting. Within another 10,000 years, a cosmic heartbeat, those intricate filaments will dissipate into interstellar space, leaving the white dwarf to fade into obscurity. For now, though, this frosty visage stands as a reminder that even in death, stars don't go quietly. They leave behind portraits etched in gas and light, cosmic messages in bottles drifting through the void. And somewhere in that icy gaze, there's a lesson about time, that what we see as a face today was once a star, and what we see as a nebula will one day become the seeds of new solar systems in an endless cycle of transformation. Amid the swirling chaos of the cosmos, where most celestial shapes twist into spirals or scatter into irregular clouds, the Red Square Nebula defies all expectations. It's a near-perfect geometric enigma. Floating in the constellation Serpens, this glowing crimson square isn't some trick of camera lenses or digital enhancement. It's a real, almost mathematical structure carved from the dying breaths of a star. What makes this nebula so astonishing isn't just its symmetry, it's the sheer improbability of such precision emerging from the violent, turbulent death throes of a sun-like star. Most planetary nebulae bloom into delicate spheres or intricate bipolar lobes, but this one, it's as if the universe grabbed a ruler and sketched a square onto the fabric of space itself. The secret to this cosmic geometry lies in the star at its heart, a luminous central engine known as MWC 922. As this aging star shed its outer layers, it didn't eject them evenly in all directions. Instead, twin cones of gas shot out in opposing jets, their edges razor-sharp, their angles unnervingly precise. Imagine squeezing a balloon from the top and bottom. The escaping air forms a ring around the middle. Now replace the balloon with a star and the air with supersonic stellar winds, and you've got the basic blueprint of the Red Square. But here's the twist. We're seeing this structure almost perfectly edge-on, with the square's glowing walls tracing the boundaries of those conical outflows like a cosmic hourglass frozen in mid-rotation. Yet even this explanation doesn't fully account for the nebula's crisp corners or that eerie, almost artificial symmetry. Some scientists point to light echoes, a phenomenon where flashes from the central star bounce off surrounding dust, creating secondary reflections that reinforce the square's outline. Others speculate about unseen companion stars, their gravitational tugs sculpting the outflow into geometric perfection. Then there's the nebula's striking red hue, a rarity among planetary nebulae, caused by rare molecular hydrogen emissions that paint the gas crimson instead of the usual blues and greens. Every layer of this puzzle reveals another question, another deviation from what astrophysics predicts. What's truly humbling is how fleeting this square will be. In another few thousand years, a mere heartbeat in cosmic time, the nebula's delicate walls will dissipate into the void, leaving behind only a cooling white dwarf. For now, though, it stands as a celestial rebuke to our assumptions, a reminder that the universe doesn't always play by the rules we've written. The Red Square Nebula isn't just a curiosity, it's a challenge. A challenge to look deeper, question harder, and remember that even in the vast, chaotic expanse of space, there's room for the inexplicable and the breathtakingly precise. 24th wonder, the Boomerang Nebula, the coldest place in the universe. If you think winters on Earth are harsh, brace yourself for the Boomerang Nebula, a cosmic freezer so extreme, it holds the record as the coldest natural place in the known universe. Located 5,000 light-years away in Centaurus, this bizarre, boat-high-shaped cloud of gas chills to a staggering 1 degree above absolute zero, colder than the frigid void between galaxies, colder even than the afterglow of the Big Bang itself. How does a nebula reach temperatures that defy the very fabric of space? The answer lies in the violent, hyper-efficient air conditioning system of a dying star. At the heart of this icy spectacle sits a fading sun, once similar to our own but now in its final throes. As it shed its outer layers, the star didn't just exhale gently, it blasted material outward at speeds approaching 370,000 miles per hour, creating a supersonic stellar wind. But here's the twist, this outflow isn't chaotic. It's funneled into two opposing jets, sculpted by magnetic fields or perhaps the gravitational dance of an unseen companion star. This bipolar expansion acts like a cosmic refrigerator, with gas rushing outward so rapidly that it can't retain heat, cooling to temperatures lower than anywhere else in nature. What makes the Boomerang truly mesmerizing is its ghostly glow. Unlike most nebulae which shine from ionized gas, this one's light comes from starlight scattering off dust like fog, illuminated by distant headlights. The nebula's eerie blue hue in Hubble images isn't just artistic license. It's the signature of microscopic grains reflecting light from the central star. Yet the coldest regions aren't where you'd expect. The deepest chill lurks in the lobe's outer reaches, where the gas has expanded farthest and thinned to near nothingness. This nebula isn't just a curiosity, it's a time capsule. The rapid expansion means we're seeing a stellar death that unfolded over just a few thousand years, a blink in cosmic terms. And there's a haunting lesson here. Even in the coldest corners of the universe, change is constant. The boomerang's lobes are still growing, still cooling, and in another few millennia, they'll dissipate entirely, leaving behind only a fading white dwarf. For now, though, this celestial deep freeze stands as a reminder. The universe doesn't just create heat and light. Sometimes it crafts perfection in the absence of both. Twisting through the constellation Gemini like celestial vipers, the Medusa Nebula unfurls its ghostly tendrils across 4 light-years of space, a cosmic gorgon whose hair isn't made of snakes, but ionized gas glowing with eerie green hues. This isn't just another dying star's shroud. It's a masterpiece of stellar alchemy, where the final breaths of an ancient sun have been sculpted by time and physics into filaments so intricate they seem almost alive. The nebula's namesake isn't mere coincidence. Those sinuous strands ripple outward with a haunting fluidity, as if frozen mid-undulation by some cosmic petrification. At the heart of this celestial spectacle lies a white dwarf, the smoldering core of what was once a star not unlike our sun. As it entered its death throes millennia ago, the star shed its outer layers in pulses, ejecting material at speeds approaching 50,000 miles per hour. But here's where the magic happens. Instead of expanding evenly, these stellar winds encountered older, slower-moving gas from earlier eruptions. The collision sculpted shockwaves into those iconic filaments, while ultraviolet radiation from the exposed core set them ablaze with ionized oxygen's signature emerald glow. It's a cosmic batik, layer upon layer of stellar material, each interaction etching finer details into the nebula's ever-evolving tapestry. Peer closer, and the Medusa reveals even stranger secrets. Hubble's sharp eye has captured delicate knots of denser gas embedded within the filaments, each one a self-contained drama where radiation and stellar winds wage war against gravity. Some of these globules are being evaporated by the white dwarf's harsh glare, trailing comet-like tails as they dissipate into the void. Others stubbornly resist, sheltering pockets of cooler molecular gas that might one day form new celestial objects. This interplay between creation and destruction isn't just beautiful, it's a living laboratory for studying how matter behaves under extreme conditions we could never replicate on Earth. What makes the Medusa truly extraordinary is its transparency. Unlike many planetary nebulae shrouded in opaque dust, this one's relatively clear, allowing us to see clear through its structure to the starry backdrop beyond. This clarity lets astronomers study its three-dimensional architecture in unprecedented detail, revealing how the filaments twist not just across our line of sight, but through depth as well. Some strands loop back on themselves like twisted ribbons, while others stretch taut as bowstrings, evidence of complex magnetic fields guiding the outflow over millennia. But the real lesson here is one of timescales. The oldest visible filaments date back roughly 10,000 years, making them contemporaries of Earth's earliest civilizations. Yet the nebula's central star has been evolving for billions of years, a reminder that what we perceive as a static image is actually a single frame in an epic cinematic reel. In another few millennia, those delicate strands will dissipate entirely, their atoms scattering into the interstellar medium to be recycled into future stars and planets. The Medusa's gaze won't petrify us, but it might just freeze our sense of cosmic time into awe-struck stillness as we contemplate the slow, beautiful death of a star and the fleeting art it leaves behind. Reaching across the southern sky like a celestial crustacean frozen mid-pinch, the southern Crab Nebula stretches its glowing claws into the void, a cosmic masterpiece sculpted by the turbulent dance of two stars locked in gravitational embrace. This isn't just another dying star's farewell. It's a rare bipolar nebula where symmetry reigns supreme, its hourglass shape so precise it seems almost engineered. At its heart lies the real architects, a binary star system consisting of a red giant and a white dwarf, their deadly waltz fueling one of the most intricate nebulae ever observed. The magic begins with the red giant, a bloated star shedding its outer layers in slow, stellar gusts. But here's where the twist unfolds. Those expelled gases don't drift aimlessly. They're captured by the white dwarf's intense gravity, funneled into twin jets that blast outward at nearly 1,000,000 miles per hour. Imagine a garden sprinkler spinning wildly, except instead of water, it's hurling star stuff across light years of space. The result, those iconic claws, lobes of glowing gas sculpted by shockwaves and stellar winds into shapes so crisp, they could be the work of a cosmic origami artist. Hubble's images reveal even wilder details, delicate rings girdling the nebula's waist like a crab's shell, hinting at periodic outbursts from the binary pair. Each ring marks a violent episode where the white dwarf siphoned too much material from its companion, triggering thermonuclear hiccups that ejected fresh layers of gas. The most breathtaking feature, though, is the filamentary structures threading through the lobe's tendrils of dust and ionized gas stretched into ethereal braids by magnetic fields. It's as if the nebula's spine is woven from invisible cosmic threads. What makes the southern crab truly extraordinary isn't just its beauty, it's the time capsule it represents. Most planetary nebulae form from single stars, their structures often chaotic or lopsided. But here, the binary system's orderly gravitational choreography imposes near-perfect symmetry, offering astronomers a rare chance to study how stellar partnerships shape stellar deaths. The red giant's slow demise fuels the white dwarf's fireworks, creating a feedback loop of creation and destruction that's still unfolding. And there's a tantalizing possibility lurking in this system. That white dwarf is greedily devouring its companion's material, inching toward a critical mass. One day, it might cross the threshold and explode as a Type Ia supernova, a cataclysm so bright it could outshine entire galaxies. For now, though, the Southern Crab Nebula remains a frozen moment in cosmic time, a testament to how even in the vast, impersonal universe, relationships between stars can craft art of staggering precision. Those glowing claws aren't just remnants, they're a love letter written in stardust, signed by two stars destined to either part ways or go out in a blaze of glory together. Hanging in the constellation Vulpecula like a cosmic hourglass running out of sand, the Dumbbell Nebula stretches its glowing lobes across nearly 3 light-years of space, a celestial masterpiece so bright and large, it was among the first planetary nebulae ever discovered. Officially catalogued as Messier 27, this glowing dumbbell isn't just another pretty sight in the telescope. It's a stellar autopsy in progress, offering us an unobstructed view of what happens when a star like our Sun exhausts its nuclear fuel and begins its slow transformation into a white dwarf. What makes the dumbbell truly spectacular is its textbook-perfect symmetry. Those twin lobes of ionized gas aren't expanding randomly. They're funneled outward by powerful stellar winds along the dying star's equatorial plane, creating a structure that resembles an hourglass suspended in the void. The central star, now a searing white dwarf hotter than 100,000 degrees, lights up the expelled material from within, making oxygen glow turquoise and hydrogen blush crimson. But the magic happens at the boundaries where these elements mix. producing delicate gradients of color that shift like ethereal watercolors under Hubble's gaze. Peer deeper and the nebula reveals its turbulent history. The outer halo, faint but vast, tells of quieter eruptions tens of thousands of years ago, when the star first began shedding its atmosphere in gentle puffs. The inner lobes, by contrast, are a snapshot of stellar violence, material ejected at speeds over 30,000 miles per hour, sculpted by shock waves into intricate filaments and knots. Some of these structures resemble comet-like streaks, their tails pointing radially away from the central star like weather vanes in a cosmic hurricane. The Dumbbell's clarity offers scientists a rare opportunity to study stellar death in minute detail. Spectroscopic observations reveal chemical fingerprints in the gas carbon, nitrogen, and even traces of heavier elements forged in the star's final convulsions. These elements won't go to waste. They'll eventually disperse into the interstellar medium, becoming raw materials for future stars and planets. In that sense, the Dumbbell isn't just a tombstone, it's a nursery in disguise, recycling stellar ingredients on a galactic scale. Yet for all its grandeur, this nebula is fleeting. The lobes expand at about 20 miles per second, thinning with each passing millennium. In another 10,000 years, they'll dissipate entirely, leaving the white dwarf to cool silently in the dark. What we're witnessing is a cosmic blink, a momentary flash of beauty in the billion-year life cycle of a star. The Dumbbell Nebula doesn't just show us how stars die, it whispers a humbling reminder that even the most familiar celestial objects, our own sun included, are bound by the same inevitable luminous fate. Locked in the gaze of Ursa Major, the Owl Nebula stares back at us, a cosmic sentinel whose haunting resemblance to wide, watchful eyes has captivated astronomers for centuries. Officially catalogued as Messier 97, this planetary nebula isn't just another dying star's shroud. It's a masterclass in celestial symmetry, its spherical shell punctuated by two eerie dark patches that peer into the void like an owl's glowing pupils. But those hollows aren't random voids, they're windows into the nebula's violent heart, where stellar winds and radiation sculpt gas into shapes both beautiful and unsettling. What makes the Owl truly mesmerizing lies in its layered structure. Unlike the chaotic debris fields of many planetary nebulae, this one boasts near-perfect spherical symmetry, a telltale sign of a star that shed its outer layers not in fits and starts, but in a slow, steady stellar breeze. At its core, a white dwarf hotter than the surface of our sun bombards the surrounding gas with ultraviolet radiation, making oxygen glow an eerie aquamarine while nitrogen tints the fainter regions crimson. But the real magic happens where those dark eyes puncture the glow. These aren't empty spaces, they're low-density cavities carved by bipolar jets, tunnels where material raced outward faster than the surrounding shell, leaving behind shadowy imprints that just happen to align perfectly with our perspective from Earth. Hubble's razor-sharp vision reveals even wilder details. The nebula's outer edges ripple with delicate filamentary structures, like frost creeping across a cosmic windowpane. These wisps betray the presence of shockwaves, regions where fast-moving stellar winds slam into slower-moving gas ejected earlier in the star's death throes. Some filaments stretch light-years long, their braided patterns suggesting the invisible hand of magnetic fields guiding the chaos. Meanwhile, the dark eyes themselves aren't perfectly hollow. Infrared observations detect faint tendrils of dust threading through them, remnants of complex molecules that survived the central star's radiation onslaught. The Owl's most profound lesson isn't just about stellar death, it's about perspective. From another angle, those iconic eye-like patches might appear as simple lobes or rings. But here, by cosmic chance, we're treated to an optical illusion so striking, it transforms astrophysics into art. This nebula challenges our assumptions about how stars die, proving that even in their final acts, they can create structures of haunting symmetry. And somewhere in that unblinking gaze, there's a silent reminder. The universe watches back, its mysteries etched not just in light but in the shadows between. Drifting through the constellation Aquarius like a celestial jewel, the Saturn Nebula earns its name not through kinship with the gas giant, but through an uncanny cosmic impersonation. From our vantage point on Earth, this planetary nebula's elongated form and glowing ansi, Latin for handles, create a perfect illusion of Saturn's iconic rings suspended in the depths of space. But this is no simple visual trick. It's a masterpiece of stellar death, where a dying star's final breaths have been sculpted into a structure so precise, it challenges everything we thought we knew about how nebulae form. At the heart of this cosmic mimic lies a white dwarf, the searing hot remnant of a sun-like star that shed its outer layers over millennia. What makes this nebula extraordinary isn't just its resemblance to Saturn, it's the layered complexity hidden within that illusion. Hubble's sharp eye reveals a nested structure, a bright inner elliptical shell cocooned by a fainter outer envelope, with delicate equatorial rings girdling the waist like cosmic hula hoops. These rings aren't solid, they're shockwaves frozen in gas, evidence of material ejected in pulses during the star's death throes. Meanwhile, bipolar jets scream outward along the polar axis at hundreds of thousands of miles per hour, carving cavities that give the nebula its elongated silhouette. The result, a celestial Russian doll where every layer tells a different chapter of the star's demise. The real enigma lies in how such symmetry emerged from chaos. Most dying stars expel their atmosphere in messy, uneven bursts. Yet here, the Saturn Nebula's structure suggests meticulous precision, like a stellar potter shaping clay on a spinning wheel. Astronomers suspect hidden forces at work. Perhaps a binary companion star's gravitational tug funneled the outflows, or powerful magnetic fields acted as cosmic sculpting tools. Infrared observations reveal another twist: dust, lots of it, microscopic carbon grains forged in the star's cooling atmosphere, form a dark equatorial band that absorbs visible light while glowing faintly in thermal infrared. This dust may hold the key to the nebula's hourglass shape, acting as a barrier that redirects stellar winds toward the poles. What's truly astonishing is the palette of colors painting this cosmic portrait. The inner regions glow vivid blue-green from doubly ionized oxygen, while nitrogen tints the outer shell's crimson. These hues aren't just for show, they're a chemical map, revealing how different elements were dredged up from the star's interior during its death spasms. The ansi themselves, those Saturn-like handles, are no mere optical flukes. They're dense knots of gas-resisting evaporation, where slower-moving material from earlier eruptions was overtaken by faster stellar winds, creating glowing hotspots at the nebula's extremities. The Saturn Nebula isn't just a pretty face, it's a time machine. Its central star completed its transformation to a white dwarf roughly 6,000 years ago, around the time humans began recording history. Now, as we study its intricate layers, we're essentially reading a stellar autobiography written in gas and light. And there's a humbling postscript. In another 10,000 years, those iconic rings will dissipate into the void, leaving the white dwarf to fade into cosmic obscurity. For now, though, this celestial doppelganger stands as a testament to nature's ability to craft perfection from pandemonium, a reminder that even in death, stars can create art that transcends imitation. Glowing in the constellation Andromeda like a forgotten ornament from some cosmic winter, the blue Snowball Nebula spins its icy brilliance across the void, a planetary nebula so perfectly round, so vividly azure, it seems almost too flawless to be natural. Catalogued as NGC 7662, this celestial sphere isn't just another dying star's farewell. It's a masterclass in stellar symmetry, where ultraviolet fury meets delicate beauty in a cooling ballet of light and gas. What makes this snowball extraordinary isn't just its color, though that electric blue is rare enough, but how its near-perfect shape defies the chaotic death throes typically seen in planetary nebulae. Most dying stars eject their atmospheres in messy, asymmetrical bursts. Here, against all odds, the result is a sphere so precise it could have been blown from cosmic glass. The secret to that icy radiance lies in the nebula's central star, a white dwarf hotter than the surface of our Sun, its ultraviolet radiation bombarding the surrounding expelled gas. Oxygen atoms stripped of electrons by this stellar fury regain their missing particles and release energy in the process, glowing with that signature cobalt hue. It's a celestial neon sign powered by atomic physics on a grand scale, but the real marvel is how uniformly this glow suffuses the nebula. Unlike many planetary nebulae with intricate filaments or bipolar lobes, the blue snowball's ionization is eerily even, suggesting its progenitor star shed its outer layers in a remarkably controlled, spherical outflow like a slow exhalation frozen in time. Peer closer, though, and subtle imperfections emerge. Hubble's sharp vision reveals faint, wispy structures within the orb, delicate radial streaks that betray the presence of shock waves. These are the fingerprints of turbulence, evidence that even this cosmic snowball wasn't formed without resistance. Some astronomers theorize the star's magnetic field acted like an invisible mold, channeling the outflow into this symmetrical shape. Others point to the possibility of a binary companion, its gravitational influence smoothing the ejector into this flawless form. Whatever the mechanism, the result is a snapshot of stellar death where chaos somehow birthed order. What's truly humbling is the timeline we're witnessing. The nebula's outer layers began expanding over 10,000 years ago, around the time humans first domesticated wheat. Yet in cosmic terms, this spectacle is fleeting. The blue snowball's gas disperses at nearly 20 miles per second, thinning with each passing millennium. Within another few thousand years, its vibrant glow will fade, leaving the white dwarf to cool alone in the dark. For now, though, this icy orb hangs in space as a reminder, even in their final acts, stars can achieve perfection, if only for a cosmic moment. And somewhere in that electric blue glow, there's a silent lesson. Beauty in the universe isn't always chaotic. Sometimes it's as precise as a snowball flung across the void. Drifting through the constellation Hydra like a faded celestial photograph, the ghost of Jupiter lingers in the night sky, a planetary nebula so large, so ethereal, it seems more like a cosmic afterimage than a physical object. Officially catalogued as NGC 3242, this faint halo of gas stretches nearly 2 light-years across, matching the apparent size of Jupiter in our night sky, but glowing with only a fraction of the planet's brilliance. What makes this cosmic spectre extraordinary isn't just its scale. It's the delicate interplay of visibility and subtlety that transforms it into an astronomer's holy grail. Through small telescopes, it appears as a misty patch barely distinguishable from the background sky. But patient observers using oxygen 3 filters or long-exposure photography unveil its true grandeur, an intricate onion skin structure of concentric shells, each a frozen ripple from the dying star's millennia-long death throes. The ghost's haunting beauty lies in its layers, both literal and metaphorical. At its core, a white dwarf hotter than 30,000 degrees Celsius bombards the surrounding gas with ultraviolet radiation, making oxygen glow an eerie green-blue while ionized hydrogen tints the outer fringes crimson. But unlike younger, more compact planetary nebulae, this elder statesman of the cosmos has expanded to near transparency, its outer edges dissipating into the interstellar medium like breath vanishing on a cold night. This very faintness reveals its age, estimated at 12,000 years since the central star shed its outer layers, making it a senior citizen among planetary nebulae, closer to fading entirely than most of its kin. What's truly mesmerizing is how this nebula rewards persistence. Under dark skies with averted vision, amateur astronomers can discern its annular structure, a smoke ring illusion caused by our edge on view of the nebula's slightly flattened shape. The central cavity, cleared by fierce stellar winds, appears darker than the glowing rim, creating that signature, ghostly face appearance. Astrophotographers prize it for the challenge it presents, capturing both the bright inner shell and the faint outer halo in a single exposure requires balancing techniques usually reserved for galaxies or comets. But the ghost of Jupiter isn't just a test of observing skill, it's a cosmic memento mori. That fading glow is the last testament of a star not unlike our Sun, a preview of what awaits our own solar system 5 billion years hence. Every atom in those expanding shells was forged in stellar nuclear fires, now returning to the interstellar medium to one day become part of new stars, planets, or even life. The nebula's current transparency offers a rare opportunity to background stars twinkle through its veil like distant lanterns, allowing astronomers to study how its gas absorbs and redirects their light, revealing chemical compositions across three-dimensional space. Perhaps most poignant is the ghost's inevitable fate. In another 10,000 years, a mere cosmic blink, its glow will fade entirely, leaving the white dwarf to cool unnoticed among the stars. For now, though, this celestial phantom lingers as a masterclass in cosmic patience, proving that some of the universe's most profound beauty isn't found in brilliant pyrotechnics, but in the quiet, fading whispers of stellar twilight. Shrinking the grandeur of its larger cousin into a pocket-sized masterpiece, the little Dumbbell Nebula floats in Perseus like a cosmic bonsai, proof that stellar deaths need not be massive to be magnificent. Officially catalogued as Messier 76, this petite planetary nebula spans barely a light year across, a third the size of its famous namesake, yet it packs all the complexity of its bigger sibling into a more concentrated package. What makes this celestial miniature extraordinary isn't just its scale. It's how vividly it demonstrates that the universe's artistic palette works just as brilliantly in small strokes as it does in grand ones. The little dumbbell's bipolar structure immediately catches the eye: two distinct lobes of glowing gas pinched at the waist by a thick dust ring, resembling an hourglass or a stretched-out infinity symbol. Unlike the smoother, more diffuse lobes of the larger Dumbbell Nebula, this version's edges appear jagged, almost fractured, as if the dying star's final breaths were more fitful. Hubble's keen vision reveals why. The central white dwarf here isn't just passively illuminating its surroundings, it's blasting twin jets of material at nearly 200,000 miles per hour, carving chaotic channels through the slower-moving outer shells. The result, a nebula that looks less like a polished sculpture and more like a celestial firework frozen mid-explosion. Zoom in on the heart of this cosmic dynamo and the plot thickens. The central star isn't alone. Spectroscopic data suggests it's part of a binary system, with a companion star either too faint or too close to resolve directly. This hidden partner may be the key to the nebula's asymmetry. Its gravitational tugs could have funneled the dying star's ejector into those bipolar lobes while simultaneously stirring up turbulence that created the jagged edges. It's a stark contrast to the larger Dumbbell Nebula's more serene expansion, proving that stellar deaths, like snowflakes, are never exactly alike. Yet for all its petite proportions, the little Dumbbell holds its own in celestial chemistry. The same elements that paint its larger cousin oxygen glowing teal, nitrogen blushing red shine here with equal brilliance, just on a more intimate canvas. Infrared observations reveal something else remarkable, a vast, faint outer halo that quadruples the nebula's true size. This gossamer envelope is the star's first farewell, material ejected tens of thousands of years before the inner lobes took shape, now illuminated by the central star's lingering ultraviolet glow. It's a timeline of stellar death written in gas and dust, with each layer representing a different chapter in the star's slow unraveling. What this cosmic understudy lacks in size, it makes up for in educational value. Compact and relatively nearby, just 500 light-years away, it offers astronomers a convenient lab for studying how binary stars shape planetary nebulae. Those chaotic jets and lobes provide clues about magnetic fields in dying stars, while the central binary's interactions hint at how multiple stars can choreograph each other's deaths. Even the nebula's lifespan is instructive, expanding at 25 miles per second. Its delicate structures will dissipate faster than larger nebulae, reminding us that the universe's most fleeting artworks often shine the brightest while they last. The little Dumbbell Nebula doesn't just mirror its grander twin, it complements it. Where the larger Dumbbell shows stellar death as a stately, symmetrical process, this compact version reveals the turbulence and unpredictability lurking beneath the surface. Together, they form a cosmic diptych, proving that stars, no matter their size, leave behind stories as unique as fingerprints. And somewhere in those glowing lobes, there's a quiet rebellion against cosmic expectations. Greatness isn't measured in light years, but in the richness of the legacy left behind. Floating in the constellation Lupus like a cosmic iris frozen mid-dilation, the Retina Nebula stares back at us with uncanny biological precision. Its intricate filaments and radial spokes so perfectly mimicking the human eye's light, sensitive lining that it seems less like a celestial object and more like a grand anatomical model suspended in space. Officially catalogued as IC 4463, this planetary nebula isn't just a visual metaphor. It's a forensic record of stellar death, where every delicate strand traces the shockwaves and magnetic turmoil of a sun-like star's final millennia. What makes this cosmic eyeball extraordinary isn't merely its resemblance to biology, it's how its chaotic formation somehow birthed such eerie symmetry, as if the universe itself paused to acknowledge our gaze. At the nebula's core lies the architect of this ophthalmic illusion, a white dwarf hotter than 60,000 degrees, its ultraviolet glare illuminating expelled gas like a flashlight beam catching dust motes. But unlike simpler planetary nebulae that expand in smooth shells, the retina's structure is a labyrinth of complexity. Dozens of filamentary spokes radiate outward like retinal blood vessels, each one a dense ridge of gas sculpted by stellar winds slamming into slower-moving material ejected earlier. These aren't static sculptures. Hubble's time-lapse observations reveal subtle movements over just a few years, proving we're witnessing real-time stellar archaeology. The faint concentric rings encircling the central star add another layer of mystery, each one a fossilized pulse, a timestamp from when the dying star coughed out its atmosphere in rhythmic heaves spaced centuries apart. What truly baffles astronomers is the precision behind this organic appearance. most planetary nebulae form messy, asymmetrical shapes as their progenitor stars wobble during death throes. Yet here, the retina's spokes maintain near-perfect radial symmetry across 2 light-years of space, as if guided by invisible spokes on a cosmic wheel. The leading theory involves magnetism. The dying star's magnetic field, amplified as its core collapsed, may have funneled ionized gas into those filamentary patterns, like iron filings aligning around a magnet. Supporting this, spectroscopic analyses detect heightened ion concentrations along the filaments, suggesting magnetic fields indeed herded certain elements into specific pathways. But the retina's most haunting feature is its transparency. Unlike many nebulae shrouded in obscuring dust, this one's gas is diffuse enough to see clear through to the starry backdrop beyond, giving the unnerving impression of peering through an actual celestial cornea. Infrared views pierce even deeper, revealing previously hidden structures, delicate loops of material arcing between the spokes, likely formed when stellar winds abruptly changed direction during the star's death spasms. Some of these loops glow with the molecular fingerprints of complex carbon chains, raw materials that may one day seed new planetary systems. This nebula isn't just a static monument, it's a time lapse in progress. The white dwarf's winds still blast outward at nearly 400,000 miles per hour, sculpting the nebula in real time. Calculations suggest the entire structure will dissipate within another 10,000 years, a fleeting moment in cosmic terms. For now, though, the Retina Nebula remains both a masterpiece and a mirror, reflecting not just the violence of stellar demise but also, in its uncanny biological mimicry, the profound connections between the microscopic and the astronomical. Those glowing filaments aren't just remnants of a dead star. They're a reminder that the universe often repeats its patterns across scales, from the capillaries in our eyes to the vast structures light years wide. And somewhere in that cosmic gaze, there's a silent challenge to keep looking deeper, because every answer uncovered only reveals more breathtaking questions. Hovering in the constellation Lepus like a celestial doodle sketched across the cosmos, the Spirograph Nebula whirls its hypnotic patterns into the void, a planetary nebula so geometrically precise. It seems less like a natural phenomenon and more like some divine hand turned the gears of a cosmic toy. Officially catalogued as IC418, this intricate marvel doesn't just glow its spirals, its nested loops and concentric rings unfurling with a symmetry that rivals the most meticulous spirograph drawings. But this isn't child's play. It's astrophysics at its most elegant, where a dying star's final breaths have been sculpted into a masterpiece of timed outbursts and magnetic choreography. At the heart of this cosmic artistry lies a white dwarf, the smoldering core of a star that once resembled our Sun. As it shed its outer layers, this star didn't erupt in a single, chaotic burst. Instead, it pulsed like a metronome, ejecting material in rhythmic waves spaced centuries apart. Each expulsion rippled outward, encountering the remnants of previous outbursts, creating shockwaves that stacked like tree rings, a stellar autobiography written in glowing gas. The result, those mesmerizing loops, each one a fossilized heartbeat of the star's demise. Hubble's razor-sharp vision reveals even finer details, delicate braids within the rings, hinting at magnetic fields twisting the outflow like invisible fingers shaping cosmic clay. What's truly astonishing isn't just the nebula's beauty, it's the sheer improbability of such precision. Most dying stars produce lopsided or fragmented nebulae, their ejectors scattered by uneven forces. Yet here, against all odds, the spirograph's symmetry reigns supreme. The secret may lie in the star's rotation. As it collapsed into a white dwarf, it likely spun faster, its magnetic field intensifying into a cosmic loom that wove the expanding gas into these orderly patterns. Alternatively, an unseen companion star could have orchestrated this precision, its gravitational tugs acting like a conductor's baton for the stellar winds. The nebulous palette deepens the wonder. The innermost rings glow vivid turquoise from doubly ionized oxygen, while nitrogen tints the outer regions ruby red. This gradient isn't just decorative, it's a chemical timeline. The oxygen-rich inner zones betray material forged deep in the star's core, now exposed by its death throes, while the nitrogen-dominated outer layers reflect cooler, less processed gas expelled earlier. Even the empty spaces between rings hold secrets. Faint, ghostly filaments stretch across the gaps, evidence of turbulent eddies where faster-moving material overtook slower waves. But the spirograph's most profound lesson is one of scale. Those loops, so perfect they could have been drawn with a compass, span distances that dwarf our solar system. The entire nebula stretches nearly a third of a light year, a sprawling canvas where physics and artistry collide, and like all planetary nebulae, it's fleeting. Within another 10,000 years, those intricate rings will dissipate into the interstellar medium, their atoms destined to recycle into new stars or planets. For now, though, the Spirograph Nebula spins on a reminder that even in death, stars can leave behind not just chaos, but geometry so exquisite it borders on the miraculous. Drifting through the constellation Musca like a celestial heirloom dropped among the stars, the engraved Hourglass Nebula glows with an almost mechanical precision, its pinched waist and luminous rings so meticulously crafted. They seem less like stellar debris and more like a cosmic timepiece designed to measure the universe's slowest moments. Catalogued as Mycen 18, this young planetary nebula doesn't just resemble an hourglass, it functions as one, its structure encoding the final millennia of a dying star's life with startling clarity. What makes this cosmic chronometer extraordinary isn't just its beauty, it's the violent astrophysics behind that deceptive symmetry, where magnetic forces sculpted chaos into geometric perfection. At first glance, the nebula's iconic shape appears simple. Two glowing lobes connected by a narrow waist, their surfaces etched with concentric rings like grooves on a vinyl record. But Hubble's razor-sharp images reveal a far more dramatic story. Those lobes aren't static bubbles, they're supersonic tsunamis of gas, racing outward at over 600,000 miles per hour. The pinch at the waist, that's the work of an invisible cosmic vise, the progenitor star's magnetic field, amplified to unimaginable strengths as the star collapsed into a white dwarf. Like a sculptor's hand squeezing wet clay, these magnetic forces funneled the star's dying breaths into bipolar jets, carving the nebula's hourglass silhouette with almost mathematical precision. The real magic, though, lies in those glowing rings, each one a timestamp in the star's demise. Unlike the smooth shells of older planetary nebulae, the engraved hourglass's rings are crisp and discreet, suggesting the star didn't shed its atmosphere in a steady wind but in violent hiccups spaced centuries apart. Picture a tree's growth rings, but instead of marking seasons, each band captures a stellar convulsion, a pulse where the star ejected another layer of its soul into the void. Spectroscopy reveals even wilder details. The ring's chemical composition shifts subtly from one to the next, proving the star was dredging up deeper, hotter material with each eruption. What's truly humbling is how recently this celestial clock was set. The outermost rings began expanding barely 1,000 years ago, around the time Vikings reached North America, while the innermost structures are fresher than the Renaissance. We're witnessing this nebula's adolescence, catching it before stellar winds blur its intricate etchings. Even the central white dwarf is a newborn by cosmic standards, its surface still blazing at over 50,000 degrees Celsius, hot enough to make the surrounding gas fluoresce in electric blues and golds. But the engraved hourglass isn't just a relic, it's a laboratory. Those perfectly aligned rings allow astronomers to measure expansion speeds with unprecedented accuracy, turning the nebula into a natural stopwatch for stellar evolution. By tracking subtle shifts in the ring's positions over just a few years, scientists have calculated the nebula's age to near-perfect precision, a feat impossible with most cosmic objects. Even the nebula's waste holds secrets. Faint, braided filaments within the pinch suggest magnetic field lines frozen in time, offering clues about how stars channel their final energies. Yet for all its precision, this cosmic timepiece is fleeting. Within another 10,000 years, a mere tick on the universe's clock, those exquisite rings will dissipate into the interstellar medium, their atoms recycled into future stars. The engraved Hourglass Nebula doesn't just measure time, it embodies it, reminding us that even the most meticulous structures in the cosmos are temporary. And somewhere in those glowing grooves there's a silent lesson. The universe doesn't just create chaos. Sometimes, against all odds, it crafts order so perfect it could pass for art. Pouring through the constellation puppies like a celestial jack-o'-lantern after a cosmic collision, the Calabash Nebula presents one of the most chaotic and strangely beautiful transformations in the night sky. Officially catalogued as OH231.8 plus 4.2, this protoplanetary nebula doesn't conform to the elegant symmetry of its more refined cousins. Instead, it sprawls across space like a smashed gourd, its asymmetrical lobes and knotted filaments telling the messy, violent story of a star caught between phases of its demise. This cosmic squash marks a fleeting moment in stellar evolution, the awkward adolescence between a red giant's final breaths and its eventual rebirth as a planetary nebula. At its heart, a dying star has already expelled its outer layers, but the ejected material hasn't yet been sculpted by radiation into the graceful shapes we associate with later stages. What remains is raw chaos, supersonic outflows blasting in opposite directions at over 600,000 miles per hour, their paths warped by magnetic fields or perhaps the gravitational tug of an unseen companion. The result, a structure that looks less like a deliberate creation and more like a stellar tantrum frozen in time. Hubble's gaze reveals the nebula's turbulent personality in startling detail. Twin jets of gas twist and contort, their trajectories skewed as if some invisible hand knocked them off course. Meanwhile, shockwaves ripple through the surrounding material, heating dust until it glows in infrared like embers scattered from a celestial forge. The asymmetry is so pronounced that some regions appear shredded, as though the star's death throes were accompanied by a cosmic whirlwind. What makes the Calabash truly fascinating isn't just its disorder, it's the physics behind the pandemonium. Protoplanetary nebulae like this one are notoriously short-lived, lasting barely a few thousand years before evolving into their more recognizable planetary nebula forms. In that brief window, we catch stars in the act of reinvention, their once stable structures unraveling into tempests of gas and radiation. The Calabash's violent outflows are essentially growing pain's stellar material, learning to navigate its new reality without the stabilizing force of nuclear fusion. Yet even in this chaos, there's a strange kind of artistry. The nebula's orange hues, courtesy of nitrogen and sulfur emissions, blend with ethereal blues from scattered starlight, giving it the appearance of a cosmic watercolor gone rogue. And hidden within those turbulent streams are the building blocks of future cosmic wonders, molecules like hydrogen cyanide and silicon monoxide, forged in the star's death throes and destined to seed new generations of stars and planets. The Calabash Nebula doesn't just show us how stars died, it shows them fighting the process every step of the way. There's no graceful surrender here, no orderly transition. Just a star thrashing against the inevitable, leaving behind a masterpiece of beautiful wreckage. And in that defiance, there's a lesson. Even in the universe, not all transformations are tidy. Some of the most captivating stories are written in the scars of struggle. In the quiet expanse of Leo, where stars burn with steady warmth, an anomaly glows with an otherworldly chill, the frosty Leo Nebula. This cosmic snowball defies expectations, its icy blue tendrils stretching through space like frozen breath against the void. Unlike the fiery hues of most nebulae, this protoplanetary spectacle shimmers with a wintry pallor, a result of starlight scattering off microscopic dust grains finer than powdered snow. These particles, rich in silicates and frozen hydrocarbons, act like celestial glitter, refracting the central star's light into a palette of frosty blues and faint violets, as if winter itself were painted across the cosmos. At the heart of this chilling beauty lies a star in transition, no longer the stable giant it once was, not yet the white dwarf it will become. Caught in the briefest of cosmic phases, perhaps a mere 1,000 years in duration, it's shedding its outer layers in slow, asymmetrical gusts. Twin jets of gas surge outward at conflicting angles, sculpting the nebula's distinctive bipolar shape less like a perfect hourglass and more like a lopsided snowman melting under an unseen sun. Hubble's keen eye reveals the chaos beneath the frost, braided filaments of dust, shockwaves rippling through the lobes, and delicate structures that resemble ice crystals magnified a billionfold. What makes frosty Leo truly mesmerizing isn't just its appearance, it's the physics behind its glow. The nebula's dust doesn't emit its own light. Instead, it mirrors the central star's radiation like a cosmic disco ball. The blue tint, that starlight stripped of its warmer wavelengths by the dust's selective scattering, the same phenomenon that turns Earth sky azure. Yet here, the effect is amplified by the sheer density of particles, a haze so thick, the star appears as a hazy smudge rather than a pinpoint of light. Infrared observations peel back the veil, exposing the star's searing surface and the intricate dance of heated dust spiraling outward. This nebula is a ticking clock. Protoplanetary phases blink by in cosmic terms, and frosty Leo's delicate structures are already dissipating. The central star's intensifying radiation will soon ionize the expelled gas, transforming this icy relic into a fully fledged planetary nebula with hotter, brighter hues. For now, though, it lingers in its wintry transition, a reminder that even stars experience seasons, and that the universe's most breathtaking artistry often lies in its fleeting, in-between moments. And there's a deeper lesson in those frosty tendrils. The very dust that paints this nebula blue was forged in the star's cooler outer layers, where molecules could clump together in the cold quiet of space. These same grains might one day seed future planets or even life, proving that endings in the cosmos are never final, just transformations waiting to unfold. The frosty Leo Nebula doesn't just show us a star's death, it whispers of winters past and springs yet to come, written in the language of light and shadow. The Red Spider Nebula sprawls across the constellation Sagittarius like a celestial predator caught mid-strike, its crimson tendrils stretching 2 light years from tip to tip, a web of ionized gas woven by one of the hottest white dwarfs ever discovered. This isn't just another planetary nebula, it's a cosmic arachnid in action where stellar winds scream through space at 4 million miles per hour, shredding the dying star's outer layers into filaments so fine they resemble silken threads. What makes this nebula extraordinary isn't just its sinister shape, it's the violence behind that delicate appearance. a reminder that even in death, stars can unleash forces beyond imagination. At the heart of this cosmic web lurks the engine of destruction, a white dwarf so scorching, its surface temperature exceeds 200,000 degrees. To put that in perspective, our Sun's surface simmers at a mere 5,500 degrees. This stellar remnant doesn't just glow, it bombards the surrounding nebula with enough ultraviolet radiation to strip electrons from atoms at a staggering rate, lighting up oxygen in electric blues and hydrogen in deep reds. But the real architects of the spider's silhouette are those supersonic winds. Imagine a hurricane with winds 1,000 times faster than anything on Earth. Now scale it up to stellar proportions, and you've got the gale-force tempest sculpting this nebula's intricate filaments. Hubble's razor-sharp gaze reveals the web's finer details. What appears as smooth lobes from afar unravel into thousands of microscopic strands, each one a shockwave frozen in gas. Some twist like spiral staircases, evidence of magnetic fields channeling the outflow into helical patterns. Others terminate in glowing knots where denser clumps of material resisted evaporation. These aren't static structures. Time-lapse observations show subtle movements over just a few years, proving we're witnessing stellar material being stretched and torn in real time. The nebula's famous legs aren't limbs at all, they're tunnels carved by bipolar jets, their paths cleared by particle beams moving at nearly relativistic speeds. What's truly unsettling is how this arachnid analogy holds up under scrutiny. Like a real spider's web, the nebula's structure is both fragile and functional. Those filaments act as cosmic conductors, transporting energy from the central star outward while simultaneously trapping and compressing pockets of cooler gas. Infrared observations reveal shadowy globules hidden in the strand's potential cocoons for future star formation, proving even predators can inadvertently create nurseries. The resemblance runs deeper. Just as spiders recycle their webs, the red spider's material will eventually disperse into the interstellar medium, destined to be rewoven into new celestial objects. Yet for all its fury, this nebula is fleeting. The same winds crafting its beauty are also erasing it, thinning the filaments with each passing millennium. In another 10,000 years, a blink in cosmic time, the web will dissipate entirely, leaving the white dwarf to cool alone in the dark. For now, though, the Red Spider Nebula remains a masterpiece of stellar thermodynamics. Its crimson threads a reminder that the universe's most breathtaking artistry often arises from its most violent processes. And somewhere in that tangled glow, there's a silent lesson. Even in destruction, there's precision, and even in chaos, there's a pattern waiting to be decoded. Swimming through the constellation Aura like a phantom of the cosmic deep, the Stingray Nebula glows with the fragile light of stellar infancy, the youngest planetary nebula ever discovered, caught in the act of being born. This celestial creature, catalogued as Hen 3135, isn't just another dying star's shroud. It's a time capsule, a living fossil preserving the first breaths of a nebula's existence. What makes this cosmic stingray extraordinary isn't just its youth, estimated to have begun forming barely 40 years ago, but how rapidly it's evolving, changing visibly within a human lifetime in ways most nebulae take millennia to accomplish. At the heart of this delicate structure lies a star in metamorphosis, a once stable sun now shedding its outer layers as it transitions into a white dwarf. But unlike older planetary nebulae with their sculpted lobes and intricate filaments, the stingray's form is still raw, its edges blurred like wet ink on cosmic paper. Hubble's observations reveal a nebula in flux. Faint, asymmetrical wings of gas stretch outward, their shapes shifting as stellar winds plow through surrounding material at speeds topping 200,000 miles per hour. The central star, hotter than 50,000 degrees, bathes the gas in ultraviolet radiation, making it fluoresce in eerie aquamarine, a color rarely seen in older nebulae where oxygen emissions typically dominate. What's truly astonishing is the nebula's transformation over decades. Images from the 1990s show a markedly different structure than those taken today, the outer edges expanding, new knots of denser material condensing like beads on a celestial string. This real-time evolution offers astronomers something unprecedented, a front-row seat to the violent processes that shape planetary nebulae during their formative years. Most nebula studies are like examining a finished sculpture. Here, we're watching the chisel strike the marble. Yet for all its scientific value, the Stingray Nebula holds an elegiac beauty. Its faint glow, 10,000 times dimmer than the iconic Ring Nebula, betrays its youth. Without sufficient time for the central star's radiation to fully excite the expelled gas, the nebula remains ethereal, almost ghostly compared to its older, brighter cousins. Infrared observations reveal another layer of mystery. Vast amounts of dust, likely forged in the star's cooler outer layers before its dramatic collapse, now drift through the nebula like cosmic pollen. Some of these grains may one day seed future planets, carrying stardust from one generation of celestial objects to the next. The Stingray's fragility is its defining feature. Unlike mature nebulae that persist for tens of thousands of years, this newborn may dissipate within centuries, its delicate structure no match for the relentless stellar winds carving it apart. For now, though, it swims through the cosmic ocean as a reminder. Even in the vast, ancient universe, there's room for fleeting wonders, moments of transition so brief we're lucky to witness them at all. And somewhere in that faint blue glow, there's a lesson that endings and beginnings are often the same thing, just seen from different points in time. Fluttering through the constellation Ophiuchus like a cosmic insect frozen mid-flight, the twin-jet nebula stretches its iridescent wings across space, a celestial butterfly sculpted not by gentle breezes, but by supersonic stellar winds screaming at 500,000 miles per hour. Officially catalogued as M29, this bipolar planetary nebula doesn't just resemble a butterfly. It captures the very essence of metamorphosis, its delicate lobes unfurling as the dying star at its core sheds its outer layers in an explosive transformation. What makes this celestial insect extraordinary isn't just its symmetry, it's the violent precision behind those perfectly opposed jets, each one a particle beam so narrow and focused, it could thread a cosmic needle across light years of space. At the heart of this stellar chrysalis lies a binary star system, two stars locked in a gravitational embrace, their dance choreographing the nebula's intricate shape. As the primary star exhausted its nuclear fuel, it swelled into a red giant, only to collapse into a white dwarf, ejecting its atmosphere in pulses. But here's where the magic happens. The companion star's gravity funneled that outflow into twin jets, channeling chaos into geometric perfection. These aren't gentle streams, they're particle accelerators in nature's laboratory, hurling material at velocities approaching 10% the speed of light. The result, a butterfly with wings sculpted by pure kinetic fury, their edges glowing from the shockwaves where stellar winds slam into slower-moving nebula material. Hubble's sharp eye reveals the wings in staggering detail. Each lobe shimmers with layered colors, oxygen glowing aquamarine near the core, nitrogen tinting the outer rims crimson, and dust scattering starlight into ethereal blues. But the real marvel is the fine structure within those wings. Delicate ripples and braided filaments trace the paths of ancient stellar pulsations, like growth rings in a cosmic tree. Meanwhile, the jets themselves, visible as pencil-thin streaks piercing the nebula's waste, leave turbulent wakes. their supersonic passage carving helical grooves in the surrounding gas. It's as if the universe took a sculptor's tool to the very fabric of space, etching motion into fixed form. The Twin Jet Nebula isn't just a static sculpture, it's a time lapse in progress. Those iconic wings expand by 50 million miles every year, their structure evolving visibly over decades. Astronomers have caught the central stars in the act of shaping their surroundings, their radiation pressure puffing the nebula like glassblowers inflating molten glass. Yet for all this violence, there's fragility here too. The wings are gossamer thin by cosmic standards, their material so tenuous, it would qualify as a laboratory vacuum on Earth. Within another few thousand years, they'll dissipate entirely, leaving the binary stars to fade into obscurity. What's truly humbling is how this cosmic butterfly mirrors its earthly counterparts. Just as a caterpillar's transformation seems violent yet yields beauty, so too does a star's death create splendor from destruction. The Twin Jet Nebula doesn't just show us stellar demise, it reveals how even in the vacuum of space, nature finds ways to echo its most familiar patterns. And somewhere in those shimmering wings, there's a silent lesson. The universe doesn't distinguish between endings and beginnings. It only knows transformation written in light, sculpted by wind, and glowing, however briefly, for those who know how to look. Hanging in the constellation Sagittarius like a forgotten wedge of cosmic citrus, the Lemon-Slice Nebula gleams with a deceptively simple glow, a planetary nebula so perfectly round, so vividly golden, it could float atop some celestial glass of iced tea. Officially catalogued as IC3568, this zesty wonder isn't just another dying star's farewell. It's a masterclass in how the universe can disguise staggering complexity beneath a seemingly straightforward facade. At first glance, its structure appears almost elementary, a bright, compact core surrounded by a smooth, yellowish halo, like a slice of lemon dropped onto the black velvet of space. But peer deeper, and this citrusy illusion unravels into a whirlwind of astrophysical drama. The nebula's sunny hue comes from a cocktail of ionized gases, primarily helium and nitrogen, excited by the ultraviolet fury of the central white dwarf, a stellar remnant hotter than the surface of our sun. Unlike the chaotic, filamentary structures of older planetary nebulae, the Lemon-Slice's smooth glow hints at its youth. Astronomers estimate it's been expanding for barely 1,000 years, a blink in cosmic terms, meaning we're catching it just as the star's death throws transition from violent eruption to graceful dissipation. The symmetry is no accident. It suggests the progenitor star shed its outer layers in a remarkably steady, spherical outflow, free from the disruptive gravitational tugs of companion stars or the warping influence of strong magnetic fields. Yet beneath that polished surface, turbulence simmers. High-resolution images reveal subtle striations in the nebula's outer edges, delicate ripples that betray the presence of shock waves, where faster-moving stellar winds collide with slower ejecta from earlier eruptions. These faint wrinkles are like growth rings in a tree, each one marking a pulse in the star's death spiral. Even more intriguing are the chemical gradients hidden within that golden glow. Spectroscopy uncovers a layered composition, oxygen-rich zones near the core, where material forged in the star's final nuclear fires now fluoresces, while nitrogen dominates the outer halo, a relic of cooler atmospheric layers expelled before the star's dramatic collapse. What truly sets the Lemon-Slice apart is its transparency. Unlike many nebulae shrouded in obscuring dust, this one's gas is diffuse enough to act like a cosmic stained glass window, allowing astronomers to study the central star with rare clarity. That star, now a white dwarf, is a frenetic dynamo, its radiation so intense, it's evaporating the innermost layers of the nebula even as we observe them. Over time, this relentless erosion will reshape the lemon slice, thinning its golden halo until it dissolves into the interstellar medium. But the nebula's legacy won't end there. Those expelled gases carry heavy elements, carbon, oxygen, and more that will one day seed new stars, planets, or even life. In that sense, the lemon slice isn't just a cosmic still life, it's a recycler, transforming the remnants of a dead star into ingredients for future cosmic recipes. And somewhere in that golden glow, there's a tart reminder. Even the simplest celestial objects often hold the most surprising depths if we only take the time to look beyond their surfaces. Tucked away in the constellation Cygnus like a celestial trophy waiting to be claimed, the soccer ball Nebula dazzles with its uncanny resemblance to the world's most beloved sporting icon. Officially catalogued as NGC 6886, this planetary nebula doesn't just hint at a soccer ball's familiar pattern. It nails the geometry with a hexagonal symmetry so precise it could pass for a cosmic thief or match's abandoned plaything. But this isn't a toy left behind by interstellar athletes. It's a dying star's final masterpiece, where astrophysics and artistry collide in a display of near impossible perfection. At the heart of this cosmic kickabout lies a white dwarf, the collapsed core of a star that once resembled our Sun. As it shed its outer layers, something extraordinary happened. Instead of expanding into the usual spherical or bipolar shapes, the ejected gas formed a series of interlocking hexagonal panels, each one outlined by glowing ridges of ionized material. The effect is staggering, a celestial buckeball floating in the void, its structure so orderly, it defies the chaotic nature of stellar death. Hubble's close-ups reveal the intricate details. The stitching between panels isn't just visual flair but shockwaves frozen in gas, where faster-moving stellar winds collided with slower ejecta to create these crisp, geometric borders. The secret to this soccer ball's flawless form likely lies in magnetism. The central star's magnetic field, amplified as the core collapsed, may have acted like an invisible mold, channeling the outflowing gas into these hexagonal pathways. Picture a child blowing bubbles through a wireframe, except here, the frame is made of magnetic field lines, and the bubble is a star's entire atmosphere. Supporting this theory, spectroscopic studies detect heightened concentrations of ionized particles along the panel edges, suggesting magnetic forces herded charged material into these precise configurations. There's another tantalizing possibility. The star's rotation could have spun like a top as it died, its centrifugal force flattening the ejecta into this faceted shape. What's truly mind-bending is the nebula's color palette. The panels glow predominantly in electric blue, a signature of doubly ionized oxygen, while the stitches between them shimmer ruby red from nitrogen emissions. This isn't just for show, it's a chemical map of the star's death throes. The oxygen-rich zones trace material forged deep in the star's core, now exposed by its collapse, while the nitrogen-dominated borders mark cooler, outer layers expelled earlier. Even the nebula's transparency plays a role. Unlike denser planetary nebulae, this one's gas is diffuse enough to let background stars twinkle through, giving the illusion of light reflecting off an actual ball's surface. But the soccer ball nebula isn't just a pretty face, it's a cosmic coach, teaching us new plays about stellar evolution. Most dying stars produce nebulae with smooth curves or chaotic filaments. This one's geometric perfection suggests a rare set of conditions, a star with just the right mass, magnetic field strength, and rotation speed to sculpt its farewell into polygons. It's a reminder that the universe's rulebook has pages we've yet to read, and that even in death, stars can surprise us with their creativity. And like all great matches, this spectacle has a time limit. The nebula's panels expand at nearly 20 miles per second, thinning with each passing millennium. Within another 10,000 years, they'll vanish entirely, leaving the white dwarf to cool alone in the dark. For now, though, the soccer ball nebula floats as a testament to nature's ability to blend precision with chaos, a cosmic game where the final score isn't measured in goals, but in the sheer audacity of its design. And somewhere in those glowing hexagons, there's a lesson. Even the universe enjoys a perfect pass. Hanging in the constellation Sagittarius like a celestial heirloom forgotten among the stars, the Necklace Nebula glows with aristocratic elegance, a loop of luminous pearls strung across space with such precise spacing, it seems crafted by cosmic jewelers' hands. This isn't just another planetary nebula, it's a stellar collaboration frozen in time, where two stars choreographed their mutual demise into a structure of breathtaking symmetry. The pearls themselves are 30 dense knots of gas, each twice the size of our solar system, glow electric blue from the ultraviolet fury of the central binary pair. Their perfect equidistance, a puzzle that defies the chaotic nature of stellar death. At the heart of this cosmic accessory whirls a stellar dance partner unlike any other. The primary star, now a searing white dwarf, shares its orbit with a companion so close, their mutual gravity locked them into a synchronized death spiral. As the larger star expanded into a red giant, it didn't just shed its atmosphere, it practically fed it to its partner, creating a swirling disk of material that funneled ejecta into an equatorial ring. But here's where physics becomes art. That disk fragmented under gravitational instability, collapsing into discrete clumps like droplets forming on a spider's web. The result, a necklace strung not by chance, but by the precise interplay of orbital mechanics and hydrodynamics. Hubble's sharp gaze reveals even wilder details. Each pearl isn't a static bead but a dynamic structure, its leading edge plowing through interstellar space at 60,000 miles per hour, leaving glowing bow shocks in its wake like ripples from a speedboat. The space between pearls isn't empty either. Delicate filaments of gas stretch between them, evidence of material evaporating under the central star's radiation. Infrared observations uncover another surprise: two faint, spherical shells surrounding the necklace like jewel box padding, remnants of quieter mass lost episodes before the star's final, dramatic unraveling. What makes this nebula truly priceless is its rarity. Among the thousands of known planetary nebulae, only a handful exhibit such perfect ringed structures, and none with such exquisite clumping. The necklace's flawless geometry requires a perfect storm of conditions, a binary pair with just the right mass ratio, orbital separation, and alignment to our line of sight. Even the nebula's vibrant colors tell a story. The pearl's aquamarine hue betrays oxygen-rich gas from the star's deep interior, while the ruby-red filaments between them reveal nitrogen expelled from outer atmospheric layers. It's a layered masterpiece, each element a brushstroke in a stellar self-portrait. But like all fine jewelry, this cosmic treasure won't last forever. The pearls are dissipating even as we observe them, their material dissolving into the interstellar medium at a rate that will render the necklace unrecognizable within another 10,000 years. For now, though, it remains a celestial testament to partnership, proof that even in death, stars can create beauty through collaboration. And somewhere in that glowing loop, there's a silent lesson. The universe's most breathtaking designs often emerge not from solitary effort, but from the gravitational pull of connection. Flip the etched hourglass nebula upside down, and time itself seems to pause, not because the universe has stopped, but because this celestial marvel has mastered the illusion of permanence. Floating in the constellation Musca like a cosmic heirloom forgotten among the stars, This young planetary nebula doesn't just resemble an hourglass, it functions as one, its narrow waist and glowing concentric rings encoding the final millennia of a dying star's life with startling precision. What makes this nebula extraordinary isn't just its symmetry, it's the violence behind that deceptive elegance, where supersonic stellar winds carved chaos into geometric perfection, leaving behind a timepiece that measures the universe's slowest moments. At first glance, the structure appears deceptively simple. Two luminous lobes connected by a pinched waist, their surfaces etched with rings as regular as grooves on a vinyl record. But Hubble's razor-sharp images reveal a far more dramatic story. Those lobes aren't static bubbles, they're tsunamis of gas racing outward at over 600,000 miles per hour. Their edges sharpened by shockwaves where faster material slams into slower ejecta. The pinch at the waist, that's the work of an invisible cosmic vise. The progenitor star's equatorial winds, focused into a relentless torrent by the star's rotation as it collapsed into a white dwarf. Picture a sculptor squeezing wet clay between their palms, except here, the hands are made of physics, and the clay is a star's entire atmosphere. The real magic lies in those glowing rings, each one a timestamp in the star's demise. Unlike the smooth shells of older planetary nebulae, the etched hourglass's rings are crisp and discrete, like tree rings frozen in light. Spectroscopy reveals they weren't formed by a steady wind, but by violent hiccups, pulses where the star ejected another layer of its soul into the void, spaced roughly 1,500 years apart. Each band carries a chemical fingerprint. Oxygen-rich inner rings betray material forged deep in the star's core, while nitrogen-dominated outer loops trace cooler, earlier ejections. It's a stellar autobiography written in gas and glow, with each chapter preserved in perfect concentricity. What's humbling is how recently this cosmic clock was set. The outermost rings began expanding barely 2,000 years ago. Around the time Rome dominated the Mediterranean, while the innermost structures are fresher than the Renaissance. We're catching this nebula in its adolescence before time blurs its intricate etchings. Even the central white dwarf is a newborn by cosmic standards, its surface still blazing at 50,000 degrees, hot enough to make the surrounding gas fluoresce in electric blues and golds. But the etched hourglass isn't just a relic, it's a laboratory. Those perfectly spaced rings act like cosmic yardsticks, allowing astronomers to measure expansion speeds with unprecedented accuracy. By tracking subtle shifts in the ring's positions over mere years, scientists have reconstructed the star's death throes down to the century, a feat impossible with most nebulae. The waist holds secrets too. Faint, braided filaments within the pinch suggest magnetic fields frozen mid-sculpture, offering clues about how stars channel their final energies. Yet for all its precision, this cosmic timepiece is fleeting. The same winds that crafted its beauty are erasing it, thinning the rings at 20 miles per second. Within 10,000 years, a mere tick on the universe's clock, those perfect grooves will dissipate into the interstellar medium. The etched hourglass nebula doesn't just measure time, it embodies it, a reminder that even the most meticulous structures in the cosmos are temporary. And somewhere in those glowing circles, there's a silent lesson. The universe doesn't just create chaos. Sometimes, against all odds, it etches order so flawless, it stops us in our tracks. Tucked away in the constellation Cygnus like a cosmic chrysalis waiting to unfurl, the Cocoon Nebula cradles the raw potential of newborn stars within its glowing embrace. This sprawling cloud of gas and dust, officially catalogued as IC 5146, isn't just another pretty splash of color in the night sky. It's a bustling maternity ward for stellar infants, where the very fabric of the nebula is being rewoven by the fierce energy of its youngest residents. Imagine a celestial incubator, its walls lined with threads of crimson hydrogen and sapphire-tinted dust, where gravity's patient pull transforms diffuse gas into blazing suns. What makes this nebula extraordinary isn't just its glow, it's the delicate equilibrium between creation and chaos. The cocoon's signature pink hues come from hydrogen gas ionized by the ultraviolet fury of BD plus 40 degrees 4124, a massive young star blazing at the nebula's heart. This stellar powerhouse doesn't just light up its surroundings, it sculpts them, its radiation carving cavities into the surrounding molecular cloud like a cosmic chisel. Yet within those carved-out hollows, hidden behind veils of dust so thick they blot out visible light, dozens of protostars are taking shape, sunlets so young, they haven't even begun nuclear fusion. Infrared telescopes pierce through the obscurity to reveal these cosmic embryos, each one swaddled in a spinning disk of debris that may one day coalesce into planets. The cocoon's structure reads like a stellar instruction manual. Dark, sinuous lanes of dust weave through the glowing gas like tangled yarn, marking regions where the cloud's density shields material from radiation long enough for gravity to work its magic. Some of these dusty filaments stretch for light years, funneling gas toward dense knots where temperatures and pressures soar, triggering the collapse that births new stars. Meanwhile, near the nebula's brightest regions, fledgling stars already unleashed from their dusty cocoons blast out jets of material at hundreds of miles per second, collimated beams that punch through the surrounding gas, creating glowing shock fronts known as Herbig-Haro objects. These jets act like cosmic umbilical cords, evidence that even newborn stars must sever their ties to the material that birthed them. But the Cocoon Nebula isn't just a static snapshot of star formation, it's a dynamic ecosystem. The same radiation that erodes the nebula's edges also compresses nearby gas, sparking new rounds of stellar birth in a self-perpetuating cycle. Massive stars forming today will one day explode as supernova, their shockwaves enriching the interstellar medium with heavy elements and triggering yet another generation of star formation. It's a reminder that destruction and creation are partners in this cosmic dance, each dependent on the other to keep the cycle turning. What's humbling is the scale of this nursery. The entire complex spans nearly 15 light-years, enough room to cradle thousands of developing solar systems simultaneously. Yet for all its grandeur, the cocoon is fleeting. Within a few million years, its gas will be blown away, its brightest stars will burn out, and the nursery will fade into the background of the Milky Way. For now, though, it stands as a luminous testament to the universe's boundless creativity, a place where darkness and light conspire to forge new suns, and where every wisp of dust holds the potential for worlds yet unborn. And somewhere in those glowing folds, there's a silent promise. Endings here are always beginnings in disguise. Deep within the constellation Cepheus, where the Milky Way's starry river flows across the night sky, a gaping void stares back, an abyss so profound, it seems the universe itself has carved out a piece of its canvas. The Cave Nebula isn't illuminated like its more famous cousins. Instead, it thrives on absence, its sprawling dust clouds swallowing starlight whole to create one of the most striking silhouettes in the cosmos. This isn't a nebula that glows, it's one that devours, a celestial cavern where darkness isn't the absence of light, but a physical presence sculpted from mountains of interstellar soot and frozen gas. What makes this cosmic cave extraordinary isn't just its shadowy appearance, it's the violent forces that shaped it. The nebula's walls, those sharply defined edges that give it such a cavernous look, are actually shock fronts, regions where supersonic stellar winds from nearby massive stars collide with the dense molecular cloud. Imagine a sandblaster hitting a cliff face at 1,000,000 miles per hour, except here the sand is made of charged particles, and the cliff is a light-year-tall pillar of cosmic dust. These collisions compress the cloud's outer layers, creating those dramatic, almost architectural ridges that frame the void. Peer into the cave's depths with infrared eyes, and the illusion of emptiness shatters. Hidden behind curtains of dust so thick they block 99% of visible light, protostars flicker to life, their heat signatures betraying stellar nurseries where gravity is stitching new suns from the darkness. Some of these infant stars are already carving their own pockets of light, blowing bubbles in the surrounding gas with their fierce radiation. It's a cosmic irony. The very material that makes the cave appear lifeless is actually the raw ingredient for creation, a stellar womb disguised as a tomb. This nebula challenges our fundamental notions of space. What looks like a simple hole in the starfield is actually a complex 3D structure, a tunnel through the interstellar medium where dust clouds nearer to us align with more distant ones, creating that illusion of depth. The darkest regions aren't empty at all. They're the densest, packed with microscopic grains of carbon and silicates, each one 1,000,000 times smaller than a grain of sand. A single teaspoon of this material, if brought to Earth, would contain more particles than there are stars in the Milky Way. Yet the Cave Nebula isn't just a passive sculpture. Its dust serves a crucial role in the galaxy's life cycle. Those same light-blocking grains shield fragile molecules from destructive radiation, allowing complex organic compounds to form on their surfaces. Some of these molecules, like water and formaldehyde, are the building blocks for life itself. In that sense, this cosmic cavern isn't a dead end. It's a factory, quietly assembling the ingredients for future solar systems in the dark. What's haunting is the scale of time at play here. The cave's current form is fleeting, perhaps just a few million years old, as the same stellar winds that shaped it are also eroding it. Those dramatic walls will eventually crumble, exposing the newborn stars within to the wider galaxy. For now, though, it stands as a reminder that darkness in the universe isn't empty. It's pregnant with possibility, a temporary veil over processes too grand and too slow for human eyes to witness in real time. The Cave Nebula doesn't just show us where light ends, it reveals where our imagination must begin. Rising from the constellation Cepheus like a phantom from an ancient spellbook, the Wizard Nebula drapes its shimmering veils across the cosmos, a celestial enchanter weaving starlight into shapes that dance between reality and illusion. Officially catalogued as NGC 7380, this sprawling emission nebula doesn't just resemble a sorcerer's cloak caught mid-swirl. It breathes with the energy of stellar apprenticeships, where newborn stars etch their incantations in ultraviolet across the gas. The magic here isn't fantasy, it's the alchemy of radiation and gravity, transforming hydrogen into glowing crimson tapestries and dust into shadowy runes. At the heart of this cosmic sorcery lies a coven of young, massive stars, some barely 1,000,000 years old, blazing with such intensity. Their ultraviolet spells ionize the surrounding hydrogen gas, making it fluoresce in vivid pinks and reds. These stellar sorcerers don't just illuminate, they sculpt. Their fierce stellar winds carve cavities into the nebula's fabric, creating voids that resemble billowing sleeves in a celestial robe. Hubble's keen eye reveals the finer incantations, delicate tendrils of dust threading through the glow like enchanted sigils, each one a region where gravity fights back against the radiation, compressing gas into dense knots that may one day birth new stars. The nebula's most bewitching feature is its layered deception. what appears as a two-dimensional cloak from afar unravels into a labyrinth of depth when studied closely. Dark globules, dense pockets of gas and dust float like shadowy familiars against the glowing backdrop, their silhouettes so crisp they seem cut from the void itself. Meanwhile, background stars twinkle through the nebula's thinner regions, their light diffused into ethereal halos, as if the wizard's cloak were woven from cosmic chiffon. Infrared observations pierce even deeper, exposing hidden stellar nurseries where protostars smolder in their dusty cocoons, not yet ready to reveal themselves to the visible universe. But the real enchantment lies in the nebula's dynamism. This isn't a static portrait, it's a spell in progress. The same stellar winds that light up the gas are also eroding it, blowing vast bubbles that expand at speeds of dozens of miles per second. Shockwaves ripple through the surrounding medium, triggering chain reactions of star formation in an endless cycle of creation and dissolution. It's a cosmic cauldron where the ingredients for new worlds are constantly stirred, simmered, and transformed. Yet for all its grandeur, the Wizard Nebula is a fleeting illusion. Within a few million years, a mere whisper in cosmic time, its glowing gases will disperse, its central stars will burn through their fuel, and the spectacle will fade like a spell at dawn. For now, though, it remains a testament to the universe's flair for drama, proving that even in the cold vacuum of space, there's room for artistry that borders on the arcane. And somewhere in those swirling mists, there's a lesson. The universe doesn't need wands or words to work its magic, just starlight, gas, and the patience of eternity. In the constellation Auriga, where ancient stargazers once charted celestial charioteers, a runaway star sets the cosmos ablaze, the flaming star Nebula. This sprawling cloud of ionized hydrogen doesn't just glow, it rages. Its tendrils of crimson and gold stretching across space like wildfire, consuming interstellar kindling. At the heart of this cosmic inferno lies Aurigae, a blue O-type star hurtling through space at over 60 miles per second, its ultraviolet fury igniting the surrounding gas into a spectacle that looks less like a nebula and more like a snapshot of celestial arson. What makes this nebula extraordinary isn't just its brilliance, it's the violence of its birth. Aurigae isn't native to this region of space. Roughly 2 million years ago, a gravitational cataclysm in the Orion Nebula catapulted it outward like a stellar cannonball, sending it plowing into this quiet molecular cloud. The collision was anything but gentle. The star's radiation, tens of thousands of times more intense than our sun's, ripped electrons from hydrogen atoms, making the gas fluoresce in that signature ruby glow. Meanwhile, its supersonic stellar winds charged particles streaming outward at millions of miles per hour carved turbulent cavities into the nebula, sculpting the illusion of flickering flames frozen mid-dance. Hubble's vision reveals the chaos beneath the beauty. Delicate filaments of dust weave through the nebula like smoke trails, their shadows backlit by the star's relentless glare. Some regions glow electric blue where starlight scatters off microscopic dust grains, creating an eerie contrast against the hydrogen's crimson backdrop. But the real drama unfolds at the shock front's jagged boundaries where Aurigae's winds slam into denser pockets of gas, compressing them until they collapse into new stars. It's a paradox. The same forces that destroy also create, turning this cosmic wildfire into an unlikely stellar nursery. The flaming star nebula is more than a pretty pyre, it's a time capsule. The nebula's structure preserves the history of Aurigae's journey, with tendrils of gas stretching backward along its trajectory like a celestial wake. Spectroscopy uncovers even wilder details. The nebula's outer edges are rich in molecules like carbon monoxide, relics of the pristine cloud the star invaded, while the inner regions blaze with the chemical fingerprints of stellar nucleosynthesis. Oxygen, nitrogen, and sulfur forged in the star's core and now splashed across the cosmos like embers from a forge. Yet for all its fury, this blaze is fleeting. Aorig's radiation is evaporating the nebula at a staggering rate, stripping away enough material to build a dozen solar systems every million years. In another cosmic blink, the flaming star will burn through its fuel, leaving behind only a cooling ember and a scattering of newborn stars to mark its passage. For now, though, it stands as a reminder the universe doesn't just create light. Sometimes it sets the heavens on fire. As we reach the end of our voyage through these 48 celestial marvels, one truth shines brighter than any star. The universe is not merely a spectator's gallery, but a grand stage where creation and destruction perform an eternal dance. Each wonder we've encountered, from Jupiter's storm-riddled skies to the delicate filaments of the Medusa Nebula, is a brushstroke in a masterpiece spanning billions of years. These aren't just distant phenomena, they're chapters in a story that connects us all, written in the language of stardust and gravitational symphonies. Consider the arcs of transformation we've witnessed: supernova scattering the elements of life across the cosmos, nebulae cradling newborn stars, galaxies colliding in slow-motion ballets. These processes aren't isolated events but threads in a cosmic fabric, weaving together physics, chemistry, and time itself. The Horsehead Nebula's shadows teach us how darkness nurtures light. The red spider's furious winds reveal how chaos breeds precision. Even the quietest corners, like the frosty Leo Nebula's icy glow, whisper that stillness is just another form of motion waiting to unfold. This journey leaves us with more than awe, it offers perspective. The Crab Nebula's relentless expansion mirrors our own quest for understanding, while the Sombrero Galaxy's perfect disk humbles us with its symmetry. Every planetary nebula, every stellar nursery, every swirling storm is a reminder. The forces shaping these wonders are the same ones that forged the atoms in our bones and the air in our lungs. We are quite literally made of the stars we admire. So what's next? The universe doesn't pause for our contemplation. Right now, in some distant arm of the Milky Way, a star is exhaling its final breath into a nebula we'll discover centuries from now. In the Orion cloud, protostars are igniting fusion in cores that may one day host planets. The cosmos thrums with activity, indifferent to clocks or calendars, yet inviting us to witness its grandeur. Carry this sense of wonder forward. Let it linger when you glimpse the Milky Way's haze on a clear night or spot Jupiter's steady glow among twinkling stars. The same curiosity that propelled this journey can fuel your own explorations, whether through a telescope, a documentary, or simply lying back on a hillside, tracing constellations with your imagination. The universe doesn't reveal its secrets easily, but it rewards those who look closely, think deeply, and dare to ask, what else is out there? Our tour ends here, but the story doesn't. Beyond these 48 wonders lie trillions more, each with its own mysteries. Some will be decoded by future generations, others may forever hover at the edge of understanding. That's the thrill of cosmic exploration. There's always another question, another horizon. So keep your eyes on the skies, your mind open to the improbable, and remember, the greatest stellar wonder of all is our capacity to marvel at them. The cosmos sings, and we are